Welcome, everybody, to the 2026 edition of Microsoft JDConf. I'm your host, Bruno Borges, and I'm excited to kick off this event in the Americas time zone. This edition is all about agents, intelligence, and modernization. How Java developers can modernize legacy systems with GitHub Copilot to then leverage LLMs, build intelligent and agentic features, integrate them into existing systems, and even scale them in production with agentic DevOps. We will dive into not just AI-assistive tooling, but agentic applications that act, coordinate, and drive outcomes. Let me start with a situation most Java developers here will recognize. You're not building a greenfield application from the start. You are maintaining a Spring service or Quark service that's been running for years, maybe a decade. It works, it's critical, it pays the bills, but every week, dependency updates, the pressure stacks up with security fixes, framework upgrades, cloud cost reviews, on-call alerts at 2 a.m. You're expected to modernize and keep up everything stable so the application can remain production safely. Now, adding AI features without breaking production, it's challenging. To move faster, but somehow with little risk, it's even more difficult. And here's the uncomfortable truth. Most of your time is not spent building new capabilities. It is spent understanding existing code, managing those upgrades, chasing incidents, and coordinating across tools and teams. That's not a Java problem. That's a workflow problem. For years, developer tools have focused on helping us developers write code faster. We started with completions, then chat. What you're seeing now is something fundamentally different: agents. Agents don't just suggest code. They take responsibility for tasks. They assess, plan, execute, and propose changes. This is the shift from tools that assist you to systems that work with and for you. And while Visual Studio Code delivers a highly integrated Copilot experience, and Visual Studio 2026 has also been optimized with agentic capabilities from Copilot built directly into the platform and whatnot, Copilot has become available in even more than just our first-party IDEs at Microsoft. We've also introduced plan mode and custom agents in third-party IDEs such as IntelliJ from JetBrains, Eclipse, and Apple's Xcode. Of course, the IDE isn't the only place developers can access Copilot. Developers who prefer to operate from the terminal can now kick off agentic workflows directly from the terminal using the new Copilot CLI. And even in the cloud on github.com, if you have an issue that you need AI to kick off a draft proposal for that, you can just assign to Copilot coding agent on github.com. We even have other coding agents, such as the coding review agent. So you have a PR, you assign to Copilot, the coding agent will review that PR for you and provide significant and meaningful feedback. Agentic workflow is the idea of these agents working for you. It's a service that can take the context, make decisions, use tools, and provide you with results. But the key thing to remember is that agents are not fully autonomous chaos. They operate with instructions, guardrails, memory, and human oversight. At the end of the day, it's going to be you who will merge that PR. As agents mature, we are seeing multiple architectural patterns emerge. Reviewer models, supervisors, network of agents, hierarchies. You don't need to pick one today. What matters is having a platform that lets you start simple, stay in control, and evolve without having to rewrite your Java application every time these patterns change. With Azure, you can use the development tools of your choice. Microsoft has some of the world's most popular development platforms, including Copilot Studio, which provides a low-code experience for process automation. and GitHub and Visual Studio Code, which are pro code and used by tens of millions of developers across the world. These tools are integrated with Microsoft Foundry, which is the AI apps and agents factory on Azure. AI solutions can be deployed and quickly scaled on Azure's application platform services and databases that offer a range of options, including managed and open source based for flexibility and are built for high reliability and availability. Microsoft provides a range of security and safety services and capabilities embedded throughout this stack to help you start secure and stay secure. Now, rather than continue talking about this abstractly, I'd like to get a real sense from a real Java application. What Ian is about to show you is a legacy Java 8 application with SOAP services and raw JDBC connection, the kind of application that many of us have inherited throughout the decades. Watch now how agents can assess, modernize, and add AI capabilities in parallel while the developer stays in full control.
Thanks, Bruno. Hello, everyone. I'm Ian. I work in AI and cloud advocacy here at Microsoft. And for this demo, I want you to imagine that I am a Java developer on a social media platform. Our competitors are innovating fast. Leadership wants us to gain market share by integrating AI-driven experiences, and the pressure is on. It's so real. The system I'm working with is a production application built on Java 8. It's stable. I mean, it runs the business. Everything works. And unfortunately, that's also the thing that's slowing us down. Normally, modernizing a Java 8 system and safely introducing AI would be a months-long effort. But we no longer have the luxury of time, just the high expectations from leadership. I want to show you Java Social. This is Java Social, a social sneaker platform where users post reviews and share their kicks. It's a real product, real users, real flows. On the surface, everything works. But under the hood, this is the kind of system many of us inherit. Multiple repositories, layers added over time, decisions that solved urgent problems years ago, but they now limit what we can do next. Let's start by understanding the system we've inherited. Instead of manually inspecting these one by one, I'm going to use GitHub Copilot Modernize in the CLI to assess the system in parallel. What you're seeing is Copilot delegating assessment to multiple cloud coding agents, one per repository, each working independently and in parallel. Let's jump over to GitHub for a moment. This is the new Agent HQ. GitHub is no longer just a place to host code, but it's a place where your agentic workflows now live. You can see each agent running in the cloud, scoped to a specific repository, independently researching and doing a deep dive. We're no longer waiting to understand one repo before moving to the next. We're getting a signal from the entire system at the same time. Now that the assessment has finished, let me jump back to the CLI. One more thing worth calling out here is that the assessment report automatically also surfaces known CVEs in dependencies. So security concerns always show up early alongside modernization and migration blockers, not as a separate phase later on. What changes here isn't the tooling. What changes is how quickly we move from uncertainty to usable signal. Something I want to make explicit is that these agents don't make architectural decisions. They surface evidence. They gather data. They identify patterns. What improves is the speed at which clarity emerges, not who makes the call. Once the agents finish, they generate reports for each repository. GitHub Copilot Modernize consolidates everything into a single report with actionable steps and recommendations. This is usually where teams stall, debating where to start, what's risky, and what can wait. The assessment report provides a mission control plane where you can view recommended actions, everything from recommended deployment targets such as AKS to upgrade and a migration plan. In this case, we see Java Social Worker and Java Social Frontend are already at Java 17. However, the backend emerges as one of the primary constraints stuck on Java 11 and 7, with the suggestion being to upgrade it to Java 21 and migrate to Jakarta EE 10 or higher. What's powerful here isn't the answer, but it's how quickly we're able to move from uncertainty to a clear, defendable starting point. With this clarity, modernization stops being abstract. It becomes targeted. So now we can use modernize in the CLI to take action. Let's jump back into the CLI and drill down into the backend repo. This time, we will start the modernization process. Copilot first generates a plan, only then executes. This ordering matters. Planning creates space for review, correction, and intent before any changes land, which is exactly how experienced teams already work. Now that Copilot is done, we see an execution summary. In addition, it opens a pull request. Everything you're seeing here is reviewable. Plans, diffs, tests, and assumptions that were made along the way. The exact same workflows you are used to continue to be the same. What changes is how fast you reach the moment where your judgment matters the most. Modernization sets up the foundation. Now we return to the original business goal that started all of this, which is adding cutting-edge AI features that improve the product experience. And this is where Microsoft Foundry enters the picture. Foundry gives us a control plane for AI, not just access to models, but a consistent way to make decisions about AI over time. It supports over 11,000 models, and that includes built-in tools to evaluate and compare them. So we can always choose the right model for a business scenario, trading off quality, cost, latency, instead of defaulting to a single option. That choice is an architectural decision, not a feature toggle. Foundry standardizes how we evaluate, govern, and observe those decisions, so we can evolve as requirements change without rewriting the system. That is what turns AI into a production concern, no longer just an experiment. With that foundation, adding an AI-powered writing assistant becomes a lot more tangible of an engineering task. Here we have a GitHub issue with a feature request, in addition to requirements for adding an AI-powered suggestions for post creation. I'm going to start with creating a plan. Let's go ahead and copy the spec and paste it into Copilot chat within our IDE. We're going to use plan mode to generate that detailed spec and implementation plan with guardrails included for Copilot. Copilot scans the code base. Copilot has intelligence built in. In this case, Copilot spins up multiple sub-agents working in parallel to more effectively scan and understand the project. This is exactly where parallelism matters the most. Once the plan looks right, we can ask Copilot to help us break the work into GitHub issues and push them to github.com. All right, Copilot has finished creating the issues. Let's go take a look. Here are the issues that Copilot created with detailed implementation instructions and success criteria. We will go ahead and assign Copilot agents to work on these issues. Once again, we get to come back as reviewers, the most important step of agentic development cycles. I just went and took a quick break, but Copilot has now finished running. So now let's go ahead and test the changes that were made. Let's validate the behavior and the implementation. So here we have the new Java social with AI features integrated. Let's create a new post for the limited edition JDConf sneakers. You can see if I put in a short generic post description, I will get feedback on how to improve. In this case, I get a 3 out of 10 with some specific suggestions on steps I can take to improve the post. Now let me go ahead and copy in a more detailed description. Let's get AI suggestions. In this case, I get 9 out of 10 ready to post. So we have it. Java Social has now integrated an AI-powered writing assistant running with GPT-4o Mini. Now let's move on to the most important step, which is deployment. Within GitHub Copilot Modernize, we can select pre-built deployment tasks that automate provisioning and deployment to Azure. Using Copilot, we can deploy this application to Azure Kubernetes Service, where Kubernetes runs it as a containerized Java service and manages replicas, scaling, and restarts. Through these pre-built deployment tasks, deployment becomes a repeatable, reliable step no matter the application. If you want to map that to platform choices later on, where the model runs, how keys are managed, how we monitor cost and latency, we can. But the most important point is that we earn that conversation by starting with Java Pain, repo reality, and then showing an AI feature that's grounded, testable, and explainable. From here, we can continue to go deeper. The hardest part of systems like this has never been the technology, but it's the uncertainty. Agentic development marks the next frontier that we've already stepped into, where assessment is faster, modernization is safer, security concerns show up earlier, and deployment becomes routine instead of a risky task. So to wrap it up, this is about faster modernization and AI features unlocked, with a lot less toil and the same control. That's it from me. Back over to you, Bruno.
All right, thank you, Ian. It is important to be clear about what does not change. Clean design still matters. Testing still matters. Code review still matters. Operational rigor still important and relevant. Agents don't replace good engineering judgment. They remove toil so great teams can move faster without sacrificing quality. Agents don't change what makes great Java teams great. They change how quickly you can move from intent to a reviewable, testable change without losing the processes that keep production stable. Now, there is this misconception that AI can only be done with Python and maybe other programming languages. Well, those are just stories. In reality, Java and many other enterprise languages do matter more than ever because it runs in the world's most critical systems. The future of agentic systems must include Java, and it must be done responsibly. Now, most enterprises aren't starting from scratch. They are standing on decades of critical applications that still run the business. Customers believe in becoming AI ready. 91% do agree. But in our research, IT leaders consistently ranked 3 top challenges with modernization projects. 1, to reduce toil. 2nd, to close skilling gaps. And 3rd, to stay secure. These challenges explain why modernization efforts often stall, not because of lack of intent, but because of the operational, technical, and security burden. When we talk about application modernization, this is where developers actually feel the difference. GitHub Copilot Modernization is designed to take Java applications that have been stuck for years and move them forward in hours and days, not months. Instead of starting with a massive rewrite, GitHub Copilot begins with a deep end-to-end assessment of your code base. It identifies risks, outdated dependencies, framework gaps, and modernization opportunities automatically. From there, agents and tools step into do the heavy lifting, such as upgrading Java versions, modernizing the frameworks, and refactoring code so the application is prepared for cloud and AI workloads, even moving to Azure. All while following best practices that you can tailor to your organization. And the key point here is control. You decide what ships. Bottom line is that we have finally been able to incorporate continuous application modernization into the software development lifecycle. Not only us, but customers as well, such as for China, that saw 70% reduction in their software migration effort. And even startups like NetVenue and BirdFi that have identified a reduction of 67% for their application modernization efforts. We have applied this across thousands of engineers, also inside Microsoft, and the results have been dramatic. Faster updates, reduced incidents, and more time for innovation. And the same applies to Java workloads. For example, in the Microsoft Quantum team, who does use Java, they had seen 80% reduction on modernization migration of Java Spring Framework. Other teams have been using GitHub Copilot for different languages for their modernization efforts. Over 90% of Microsoft engineering has been using Copilot. And Copilot is the #1 contributor of the GitHub organization itself for the past 18 months. Now, Java across Microsoft continues to be strong. We have over 2.6 million Java developers using Visual Studio Code for their Java coding experience, and over 3 million JVMs in production just inside Microsoft for our internal systems, and over 10 million players on Minecraft Java Edition already running Java 21. So the opportunity is clear, it's here, and it's achievable and tangible. Now, Microsoft continues to be deeply committed to the Java ecosystem, contributing to projects that enhance the value of decades of investment, not just from Microsoft, but also from our customers that have invested in the Java platform. And customers have noticed this. There are so many customers now than ever before who are calling Azure as their home for enterprise Java applications. And we can't wait for you to join this wall of fame as well. All right, so plenty of stuff that you saw in this keynote. And I want to make sure that you get even more excited. So while you can get started with a lot of resources, before you even dive into that, I'd like to welcome Rod Johnson, the creator of the Scalable Agentic framework for Java and creator of Spring Framework, on stage live right now. Rod, thank you so much for joining us. Please make sure your microphone is working fine. And I would like to first introduce you, because there's a lot of Java developers in the world that know you, but there might be a few that just started their career after Spring became a de facto standard and so on. So would you like to introduce yourself first? Rod, I'm afraid we are not getting your audio. Let's double check on the live stream if your audio is going through and it's an issue on my side. Yeah, we are having an issue with your microphone on your end. All right, so Rod will restart on his session on his side. Rod is in the UK right now. I'm in Montreal. Nobody asked, but hey, we're here.
Hey, can you hear me now?
All right, now we can hear you, Rod. We got the microphone, but no camera. Feels like it's either or.
Camera should also be.
There you go. All right. So
yes, are we good? We're winning.
Perfect. Welcome. So, Rod, brief introduction. Lots of developers know about Spring. Lots of developers know you, but some developers may not know who you are, what you did in the past, and what you're doing now.
So I have been working with Java pretty much since the beginning of Java, and it was that experience that led to the creation of the Spring framework in the early 2000s. But, you know, I wouldn't necessarily regard myself primarily as a Java person. I would regard myself as a person who wants to solve problems in enterprise software. And back in the early 2000s, the problems were, how are you productive with Java? In the mid-2020s, the problems are, how do you take Gen AI and make it relevant to business applications? So that's why I created an AI framework for Java.
So that framework is called Scalable, or is it Babel?
In Babel. I prefer the pronunciation in Babel, as in the Babel fish from Douglas Adams' Hitchhiker's Guide to the Galaxy.
So walk us through it. Show us what Embable is capable of and what problems does it solve for developers.
Okay, well, I'm going to firstly show a couple of slides, which hopefully everyone can see. And I'm actually going to pick up, Bruno, on one of the things you said, because, there were several things that I loved in your intro there. And one was, what does not change? And clearly we're dealing with this amazing, almost mind-blowing technology. And, it's easy to get swept away by that. But in fact, a lot of our core skills are still highly relevant. As you mentioned, testability, all those things. So here, what I'm trying to illustrate in this image is that when we think about how and where to use Gen AI, we should imagine it for every scenario, a continuum, from things that are totally autonomous and unstructured and magical on the one hand, to things that are boring, deterministic and structured. So at one end of the spectrum, we've got, say, OpenClaw, which is kind of exciting, but no sane person is going to run a business on it. To at the other end, we've got the kind of code that we've been writing for decades, which is highly structured, very much deterministic. So the way in which we work with AI enables us to select the right point along this continuum. Things like, for example, how do we mix steps between good old-fashioned code and invoking LLMs? How structured are our interactions with LLMs? How reliant are we on the LLM to determine tool choices? So, I would encourage people to think about every scenario in terms of this continuum, and Embable exists to make it easy to choose the right spot. So if you really want structure and deterministic applications, which you obviously need to use Gen AI for business purposes, you need to take big problems and break them down into smaller steps. Again, as you said, Bruno, what does not change? Since the dawn of computer science, we have decomposed problems into more manageable steps and put those steps together. So, that is an absolutely critical thing to do. And you look at some of those steps can just involve code. Some of those steps can involve LLM invocations. Those LLM invocations can themselves invoke tools. So the way in which steps are wired together is core to true agent frameworks. And there are a couple of different ways to do this. One is that you just rely on a single agentic loop. Let the LLM determine which tools to call. Can work very well, but unfortunately it is never going to be predictable and deterministic enough for use in serious business applications. Secondly, you can do what, say, LangGraph does in the Python world, which is use technology like a state machine to ahead of time wire your steps together. What Embable does is a genuine innovation on any platform. And I think important to note here that Java can and is innovating in Gen AI. And what we do is we use a non-LLM AI pathfinding algorithm called GOAP, or Goal-Oriented Action Planning, to dynamically choose paths at runtime. These paths are chosen through strongly typed Java methods. So they leverage the Java type system. GOAPs, I don't have time to explain GOAP here, but I would encourage you to read my blog. And I'm going to show you some code to see how to get started with Embable to hopefully whet folks' appetite. So what I'm showing here is code from our Java agent template. You can head to Embable, our organization, on GitHub, and you can go to the Java agent template and you can create your own template, your own repository from that in a matter of seconds. Embable is, of course, hosted on GitHub, Apache license, open source, just like Spring and most of the Java open source projects you know and love. So here I'm showing a Maven example. Of course, if you prefer Gradle, it's easy to use that. But you can see that I've just used the Spring Boot starter parent here. This is an absolutely standard Spring Boot POM. So if you're familiar with Spring and Spring Boot, Embable is going to be super easy for you to pick up. And you just put our Embable starters in. So typically you start with the Embable agent starter and a starter for whatever model you want, like OpenAI or Anthropic or Llama. By the way, when I talked about decomposing steps, another thing that I really loved was the AI Foundry. The choice of LLMs is something that you shouldn't do in one place in your application. It's something you should do for each step that invokes an LLM. And Embable makes that very easy to do. Okay, let's look at the simplest possible thing you can do with Embable. This, I think, is really important if you're talking as a Java developer to Python folk who tell you, oh, it's so easy in Python. Just show them how easy it can be in Java. So here what we have is a component where we've injected the Embable AI interface. It's a Spring at component. This is all we need to do after we've got the starters to inject the AI interface. And now we can call any LLM that is available to Embable. In this case, we're saying use the default LLM, but you could choose a specific model by name, or you can set in your configuration roles for your LLM to use. So here we are saying with the default LLM, and we're assigning an ID that would be helpful in logging. And then we're saying what type we want to create. Couple of points here. Firstly, Embable has a Fluent API, which we've put a lot of effort into, and I think it makes it extremely nice and self-documenting to use. But secondly, we're not generating a string. We are returning a type. And remember that you shouldn't just think about your LLMs as something that can generate natural language. Think about your LLMs as something that can generate a response that can be of any structure. This, because of our Fluent API's design, you're able to do what we call few shot here with strong typing. So when we're giving examples of a good animal and a bad animal, which would be respectively good and bad responses, they're strongly typed. We're not putting just free text or JSON strings in there. We are benefiting from the Java type system. And under the covers, Embable will serialize this to JSON and put it in a way that the LLM understands. And finally, we say from prompt, invent a fictional animal. So let me just run that here. This project uses the Spring Shell, very convenient to use in demos. And you can see it has invented an animal called Lumina of the species glowing ox. So let's have a look at animal to see how that happened. So animal is a Java record. Java records work particularly well with these structured return types that are very important to applications using LLMs. But also notice here, we've got a Java Beans validation annotation here. And under the covers, the framework is transparently sending it up to the LLM to explain what is valid and what's invalid. And if it gets an invalid response, it will do another loop to tell the LLM, sorry, you didn't match the validation. So at this point, Bruno, should I show a slightly more involved example, or how are we doing with time?
No, we are doing fine in time, but I want to go back to that regular expression. So Embable will send the regular expression, the pattern, to the LLM to give a hint, instead of just checking whenever it receives, right?
Yes, absolutely. So this annotation is not an Embable annotation. It's a standard Java EE annotation, or Jakarta EE annotation. But Embable understands it out of the box. So if you annotate your types this way, Embable will actually add to the initial prompt. It will add that information. So when we send prompts up to the LLM, we add additional stuff that is really important. So one of the things we add is we add the current date and time, because the LLM doesn't know that by default, and it can be very important to help drive tool use. We also, if we know it, send up the knowledge cutoff of the current model. But we also do things like if we see that there's a validation pattern, we send that up. And this brings me back to, I think the key thing about building reliable business applications using LLM. Decompose things into steps, make those steps about structure. So this is where I think Java is very compelling. because we're all familiar with the Java type system. We all have valuable domain models that have been built up over time. We can actually leverage that in our Gen AI applications. And as Java developers, I think that actually gives us a superpower that many people do not realize.
So I think what developers have to understand is there is a way to build intelligent applications. I mean, if an application calls AI and gets some chat completion, we can say it's somewhat intelligent. But it's not truly deterministic if the LLM doesn't understand what the application does. And that's what Embable helps with. It shares some of that structure that the application has with the LLM. So the LLM becomes part of the application, not just an endpoint to have a conversation with.
Absolutely, spot on. And yeah, with the GOAT planning, that takes that to another level where it actually orchestrates multi-agent workflows informed by Java types. But our entire emphasis is on being able to leverage the Java type system, being able to leverage POJOs, which obviously wouldn't be surprising to anyone familiar with the history of Spring, and being able, therefore, at each step to validate, to check, right? It makes your guardrails much easier if you know what structures you're dealing with.
100%. Rod, thank you so much for your time. Thank you so much for the demo. So if developers want to try Embable, they go to github.com/Embable framework. What is the URL? Can you show?
Yes, it's just Embable, Embabel on GitHub. And also I would encourage people who are interested in this to take a look at my blog on Medium. Just Google Medium Rod Johnson. And I think you'll find some interesting attempts to explain what, the philosophy behind Embable and why it's important for enterprise Java development.
And one last thing, during the keynote, we saw GitHub Copilot, many ways to interact with agent harness capabilities, not just GitHub Copilot, but other providers as well, like Claude and Google Gemini CLI. Do you see a future where applications are using Embable, but also integrating with those agent harness that are available in the environment or on a server side?
Look, I think Embable's at an interesting point where it's kind of, I would say the term, obviously agent harness didn't exist when I first conceived Embable, but Embable is at a point where it's kind of higher level than most other agent frameworks. So it's almost between agent harness and agent framework. One area where I think integration with agent harnesses makes a ton of sense is coding, because these things are very mature with things like, Claude Code or the Copilot coding agent. And yes, we do have integration with coding agents where you can fully integrate it into your Java apps.
Awesome.
And I mean, the other thing that I think is important, as I said, is model choice. So, I really love what you have there with the Foundry, where you can see the models, you can choose which model might be good for particular scenarios. I think that is critically important to building serious business applications with Gen AI.
Amazing. Rod, thank you so much again for your time. Thank you for this great demo and this great conversation. I wish you all the best with Embable. I see the future. I see the future is agentic. It has AI embedded in any application in the world. And I think we're all going to have fun as developers. We are not going anywhere.
I agree. Thank you.
Thank you so much, Rod. Have a good one. Welcome back. So now we're going to get into the regular schedule. And just before we invite Brian on stage, Brian from Redis, let's bring the slide with the resources on stage. So yes, so if you want to learn more about LangChain4j with Microsoft Foundry, AI Foundry that we just heard Rod mentioning, the AI Foundry service from Microsoft offers dozens and dozens, hundreds actually, of AI models that you can choose from. From a single application, you can integrate any model that is available in our catalog. Models from Google, Gemini, OpenAI, ChatGPT, Anthropic's Claude models, and Llama and Hugging Face. There are many options available, and you can build any application. The future is not single model. The future is multi-model applications, models for different tasks, for different purposes. Now, If you want to modernize applications, GitHub Copilot App Modernization, we have that capability built into IntelliJ GitHub Copilot plugin. We have that available in Visual Studio Code. And recently, we now also have this capability available through a command line interface from a tool called Modernize. You install Modernize, and you can start managing upgrades and migrations of your Java applications and .NET applications as well. Lastly, if you want to optimize your Java runtime in the cloud without having to dive into JVM tuning configuration, we have a tool called Jazz, the Azure Command Launcher for Java, where we support JVM from Java 8 all the way through Java 25. Instead of configuring heap sizing and GC or garbage collector, just ask Jazz to run your Java workload, and that JVM configuration will help you get the most of the resources allocated to your application in the cloud. Scan the QR code, and you're going to learn a lot of things that you can do with Microsoft capabilities, services, tools, and applications that will make your Java development and production experience a lot better. So let's get started with JDConf now, the regular schedule. Let's welcome on stage Brian from Redis.
Oh,
Brian, welcome.
hello, everybody. Hey, how are you, man? It's great to see you.
Great to see you
good,
too.
Good. Yeah, excited to be here.
I mean, everybody's excited. I'm having chills right now because we just had Rod Johnson on stage, and like that was amazing. Where are you based right now?
So I am based out of Scottsdale, Arizona, kind of in the suburbs of Phoenix.
Is that Phoenix, Arizona, in the
Yes,
United
correct.
States? Okay.
In the United States,
All right.
yes.
So I bet the weather is quite nice right now already.
It's actually a little too hot for this time of the year, but hey, I'll take it over rain and snow.
Awesome. Well, I'm from Montreal. Luckily, the snow is already gone, and we finally can enjoy some sun. You can see from the shade here. But Brian, what matters is memory. That is what matters. We heard from Rod the importance of applications integrated with multi-models, with agents, with tooling, with capabilities. But one thing that we didn't discuss during the keynote is memory, like how LLMs have memory and how we application developers manage the memory that is available to LLMs. And I wonder what you have to show us. So why don't you get started?
Yeah, certainly. Let's do this. So hello, everybody. I'm Brian Bowden from Redis. And today we're going to be talking about what I call the secrets of agentic memory management. And before I jump into the slides, basically we've been dealing with memory management from day one, working with the LLMs. We knew that we could do one-shot kind of interactions with the LLM. And then we tried to do the second shot, and we're like, oh, well, I forgot everything that I told it. So our first approach was to basically give it everything back. And that evolution is what I want to trace in this talk. And let's get started. So you can reach me at dsd@redis.com, also on Blue Sky, and you can basically go and Spelunk my GitHub organization and get everything that you need out of it. I'm also a proud member of the Java Champions, so obviously Java has been in my heart since 1997, and pretty much everything that we do at Redis, I'm the person that basically say like, well, I'm going to do the Java version of that. So let's get started here. The agenda for today, and hopefully I would have enough time to do this. As you can see, I speak very fast, so hopefully you can watch the recording because I want to get it all in there. So we're going to talk about the AI memory problem. That should be fairly fast because we kind of experience that day to day. Then we're going to talk about the foundational, first principles to basically learn about how we should structure, manage, and evolve our memory systems. Then I'm going to talk about the Redis Spring AI Memory Server, which is basically an experimental piece of code that I wrote based on our Python product that we have at Redis. And I used it as my kind of a experimental lab for memory management. And then in that server, there's 6 memory types. We're going to basically see how they interact in a RAG style interface. So the AI memory problem. And again, in 2022, LLMs came to the stage and they just really felt like geniuses. But every genius sometimes has a Achilles heel. And that was basically the inability to remember anything after an interaction. So basically, it kind of reminded me of I'm old enough to remember when the HTTP protocol first came to life, and we're like, we were building desktop applications, and we could basically have long-running conversations in terms of processes with our systems. And then came the web, and we were basically like working with a walkie-talkie. It's like, hey, you gotta basically do context-complete communications because HTTP was stateless. And we're kind of facing with the same problem, but at a larger level of magnitude. Instead of having a web container or a web server at the other end, we have something that can basically solve problems that we couldn't solve before. Or we needed a lot of code and a lot of patching continuously to basically get things going. So imagine that you have something like this, where you have basically an interaction with an AI, and there's something important that the AI needs to know in order to prevent, catastrophe, or prevent a business process from going awry, or anything that basically will result in either lost business or potentially some kind of fatality if this is connected to some sort of hardware. And in this case, we're talking about something very simple as basically placing a food order for a corporate team of people. And you might tell the system that you're allergic to something, or that somebody's allergic to something, and 50 messages later, you'll find out that the system completely forgot about that. In agentic systems and RAG systems, in LLM-based systems, we have a lot of maladies that happen when we try to manage the context naively. We have the famous, lost in the middle, where things just basically disappear during compaction, summarization, and things of that sort, chunking, or re-ranking. In this example, the allergy to peanuts basically disappears, and at some point, the system's going to recommend something bad. Or it might even be an automated system that basically orders through a web service from a food provider, and you might get the order and not even know that it has that ingredient that might be fatal to a coworker. So the idea, again, is to be able to treat memories as first-class citizens and basically give them all the metadata that they need to basically be retrieved at the right time, be enhanced correctly in the background when needed, and be forgotten when needed. And in this case, again, the memory as a first-class citizen, it's a system should be able to detect those memories, should be able to extract those memories during a conversation, should be able to classify them and maintain them over time, and then basically provide an effective retrieval when relevant. The early LLM applications basically relied on, hey, let's put the whole conversation back in there. Then we brought in RAG and said, well, let's put the whole conversation back in there, and everything that we can retrieve that we think it's relevant to the specific problem at hand, that the LLM doesn't happen to know already. So the first step in agentic memory is to tell the LLM to make memories about things that it doesn't know already, or that has outdated knowledge about. So if you remember RAG, we basically have a system that can typically use a vector database or a graph database or some sort of system to get relevant information out of a system of record. It could be for a company, it could be for an e-commerce system. It doesn't really matter, but the idea is that the data that it's relevant to the business, it's in that database, and we basically stuff it into the prompt before telling the LLM to reason about it. And this could be data that basically changes day to day, obviously anything after the training date of the LLM, and typically domain specific. So RAG, it's not agentic memory. RAG, it's probably our first kind of brute force approach to basically get some sort of agentic memory-like environment working. And given RAG has evolved greatly, and if you bear with me, I think that basically RAG, it's sort of a early version of agentic memory in a rough fashion. But you can see that with RAG, we basically retrieve, we basically stuff in content in the context window. We try to summarize, we try to find, we take domain data, we turn it into chunks, we basically vectorize those chunks, and then we try to use semantic searching in keyword searching and full text search to basically find the chunks that are relevant to our information, and then we rehydrate all that, try to find the parts of the documents that make sense. You might semantically hit a specific part of a document, but maybe the paragraph before that and after makes sense. And how do you do that? Well, you would have to do either semantic chunking, or you would basically have to do a look ahead and look behind to basically find out if you have the relevant information. But the problem here is that we're treating everything as text and as a big chunk of basically snippets that then we have to rehydrate and find basically what to pay attention to around that chunk. With agentic memory, we try to basically formalize that in that there are different types of memories. There's different extraction strategies for those memories. And we have now something akin of a human long-term memory, even potentially better than human long-term memory. So in general, RAG, it's a type of agentic memory. And a lot of the new concepts that come out in agentic applications can be classified as new types of memories with different retrieval strategies, with different maintenance strategies, and with different life cycles. So, for example, everybody has heard of skills. In most of the agentic coding systems, you basically can bring on a folder that contains a skill for something, and it's a collection of recipes, little scripts, things of that sort. In my mind, those are memories. And sometimes they're also suffering from the same malady that RAG suffers. It's that they're all basically glubbed up together. In how to classify them, breaking into individual skills, how to pull the ones that you need only for the task at hand, kind of how to do the progressive reveal of what a skill has. It's also very close to the heart of agentic memory management. So let's take a step back and talk about the science of memory. Basically, what the foundation is, what are the principles that we use to basically build this agentic memory systems. And it seems to be the trend across most of the vendors and providers in state-of-the-art papers, that basically we have to ground our foundations in how the human brain works, but also overlay basically the things that the human brain might not do as well that we can actually do better with computer systems. And that evolution is making our systems much more reliable and robust in this high pressure, business environments and in enterprise systems. So what is memory? It really depends on who you ask. We draw understanding in techniques, in structures from a lot of different fields. Principally psychology in terms of basically building the systems, and obviously computer science, but also in neuroscience, basically how the brain processes long-term memories, how things get compacted, how we remember things, how we fill in the blanks, how our memories change over time, and sometimes for the worse. We know that, for example, in criminal science, we know that witness testimony gets really bad over time, to the point that after a certain number of months, it's unreliable completely. And also the eyewitness testimony, when we see something, we fill in the blanks with things that we've seen before, things that we imagine happen. It could be there was a sound in the background of some event, and that sound triggers some other memory that we inject in the memory we're trying to recall accurately, therefore resulting in something that it's not. So psychology gives us the foundational view, basically what does memory do, and how in neuroscience basically gives us the formation details, how the dynamic nature of basically the wetware in our brains deals with memory, building connections, reinforcing connections, dropping connections altogether. With philosophy, we also take into account basically how agentic systems deal with users, how the user is sometimes in the agent are one thing and the same. In the agent plus user preferences, it's a reflection of our personality, and basically it's an avatar that goes there to do work on our behalf. or where you have a swarm of agents doing work on your behalf, but they all have their individual personalities. And obviously from computer science, we have learned a lot about memory, but the memory that we're familiar with, RAM, ROM, EEPROM, all those things, we have learned techniques of how to manage those at the hardware level and at the software level, in how to move them from the different parts of a computer memory that are from super fast CPU level and registers and things like that, L2 cache in that type of memory, in L1, to a RAM memory, and then to disk. And we know that in computer science, that distance between the retrieval of something from RAM and the retrieval of something from disk, or from something like a disk that it's remotely located, like object storage, it makes a big difference. So all those lessons have also are being folded into this little new world of agentic memory. So from psychology, we basically have the classification, the taxonomy of our memory systems. At the highest level, it's short-term, long-term memory, and we distinguish explicit conscious from implicit unconscious memory. And this taxonomy basically informs our memory type system. So at the high level, the process is simple. Attention triggers the encoding of a signal coming into a short-term memory. I apologize. And the short-term memories then are further encoded into long-term memories. So just like humans do, we are working with we're having some interaction with a process or with another person, and a concept comes into the conversation, the working memory maybe, and we are taking that and putting it in the back of our heads, and then similar conversations comes up, and we kind of recall that. It's like, hey, I've done something similar, or this person talked about something along the lines of that process that you're talking about, and maybe I can extrapolate some ideas from there to apply them to this. And that's kind of the same thing that happens in this agentic memory systems. You have your working memory that it can be separated from short-term memory, but you have short-term memory. In your working memory, it's basically your blackboard where you're basically doing all the work. And then from there, you're basically picking out things and storing them in long-term memory. And those things in long-term memory then can be either forgotten when they're not needed, based on things like, how often do you access a memory? If a memory keeps on getting access, it's like a cache. You basically have a hot key. You want to basically make sure that key is available very quickly. So you move it to the faster retrieval path. While there might be something that has high importance, but very, very low need recall. So maybe that's a memory that you moved obviously to long-term memory, but in long-term memory, you might basically storing that on S3 as a very cold long-term memory, but that is important, and therefore you should keep. So this type of concept comes from the field of psychology. There's a process of encoding, which basically means remembering or determining what needs to be remembered. So if everything is stored, nothing is meaningful. It's kind of like when you have an overload of information and then you don't know what to do with all the information. You don't know how to connect the dots. There's no structure to it. So selection, attention filters the input that we receive as signals from the world. And in the world of software, this could be basically a message coming into a Kafka stream, or a JMS queue if you're still into a JMS, or an email arriving to a mailbox that's being watched by an agent. So those are all signals that we have to process and figure out what things do we need to remember from these. So the encoding processes are very similar to some of the things that we do in RAG. You have chunking, you have elaboration, you have organization, you have this process to create what we call structured memory codes, or that's what they call them in psychology. In our case, it would be just a memory. So for AI systems, this means basically extracting and structuring those memories rather than just storing raw transcripts. Sometimes you can store the raw data as a backup or as a log of what has happened. But really, you want to refine these things into atomic, well-structured pieces of information that can be used effectively. And then obviously storing, we talked about this, long-term, short-term memory, and then you have the sensory store, which basically, it's probably where you're getting the stream of events coming from a system. And the more complex agentic systems get, the more Kafka-like or Redis streams-like this system has to be. It has to be able to receive things quickly and know what to discard, know what to store, know what to basically signal the system to process further. It's a pretty interesting problem that we've dealt with before, but now we have LLMs into the equation. This would involve things like, for example, TTLs, knowing how long something should live in the system. Like I said, we can't remember everything, so smart TTLs into our memories are very important. And then retrieval. Once we have all this stuff in a system, organized, classified, in nicely structured fashion, how do we retrieve them back? How do we recall? How do we, the process of basically remembering something? And as humans, we know that sometimes you're like, okay, what was that actor in that movie that had the glasses and the hat? And your brain is basically building this graph of connections, semantically connecting different things. And we know, we see how that happens to a lot of us. The image is fuzzy, and then eventually it gets clearer and clearer and clearer. And you're like, oh yeah, that's this person. And we need a system that's similar to that. But obviously, we can probably make it more efficient in a lot of cases. So being able to retrieve that information quickly typically involves vector databases with semantic searching, hybrid searching with, for example, BM25 style searches, keyword searches, full text searches, and searches over specific type of data structures. In basically combining all that stuff, re-ranking what you get back, applying either further reasoning to basically know how to provide that data to the system that it's actually needing those memories. And then from cognitive neuroscience, we basically, the most important part here is to remember how to forget. And the brain has a lot of different ways to how to forget things, but also how to consolidate and improve memories. And in the case of the humans, the system it's fairly flawed in some areas. Again, we inject things from prior experiences that might not be relevant, or we make assumptions about a process because we've seen a process that's similar to that. And that's what makes humans humans. So we're trying to replicate that, but take the things that make it a fragile process in some areas. So, and then finally, from computer science, we basically figure out how to structure this in the platforms that we have, in your L1 cache, things that should be fast, limited session scope. In long-term memory might be your disk, or it might be a database that's slower to query than your fast memory access. And then very cold memories could be object storage, as I mentioned before. So this is something that everybody's basically coming up with their separate different schemes of how to promote memories from one place to the other, how to forget things, or how to improve things that have been remembered and are deemed to be very important and very relevant to the majority of your users. So this brings into the equation things like eviction policies, how to kick something out of the memory, least recently used or least frequently used, and then just TTLs in general. And this basically blends with the whole world of logging systems and streaming systems. So very important to basically have all these concepts from computer science come back to basically help with our systems. And obviously indexing, it's part of the retrieval process of those memories, and how to have a powerful search engine that can search over whatever scheme you have decided to structure your memories under. And it could be multiple ones. There's memory systems where you have something like Redis in a vector database, basically retrieving things by keyword in semantic meaning. And then you have something like Neo4j or Falcor, where you basically might have a semantic a knowledge graph that you basically use to also search for specific things relevant to the problem. And combining all those things is basically the job of an agentic management system. So I'm going to move past this, but I want to keep in mind that also in philosophy, we have to think about how these systems behave in the face of our users. And this is more about the UX and how the UX of agentic systems is moving forward, but how memory reinforces those things. Basically, LLM-based systems are second brains for humans. So again, the short take in here, what do we mean by agentic memory? We mean a short-term memory, history in agent state. For long-term memories, we have external information, awareness, sensitivity, understanding, preferences. So you can think of a computer system nowadays as having preferences about how that agent should work, the persona of the agent. Then you have the persona of the user, the preferences of the user. Then you also have the RAG-like information that is relevant to the system. And then you also have things like skills. And then those skills will have preferences that you have evoked over time of using the skill, which are also, again, more memories. So it really, in my mind, it's all basically decomposing as how do we manage memories effectively in agentic systems. And it is, I think, at least 50% of the equation. So let me introduce the Redis Spring AI memory server, which is basically one of my experimental projects based on our open source Python agentic memory service. It started with the same implementation, and then it's slowly morphed into something different, which I mostly use for experimental purposes. But really, basically, you have applications interacting with a memory server either via REST, so it's a microservice, or via MCP. You can basically tell an LLM, it's like, hey, there's a tool to use this memory server, and you basically give it some sort of prompt that says, hey, this tool will allow you to remember things that are important to the conversation with the user, things that you might not already know from your parametric knowledge. There's basically a couple ways to use this. Obviously, I work for Redis, so I use Redis for most of the storage in here. Mostly it's JSON documents combined with the Redis query engine, and a lot of other things like basically semantic caching, semantic routing to basically do some intelligent things based on either pre-trained or continuously learned behaviors. Also, I want to make sure that you understand my take on this. It's that I think agentic systems need to learn over time. And learning, it's basically the creation of memories. So how do you create and manage those memories is going to be paramount to how this reinforcement learning of agentic systems works. Again, we have the working memory, which is a scope to the session with a user. And then we have a long-term memory, which is basically our persistent kind of a memory system. And for this demo, I've done 6 memory types. Most of them use semantic search with vector embeddings to basically do retrieval, but also combined with full text search, filtering by time, topics, entities, users, in everything that's also in the context at that point in time. So how do we actually get the long-term memories in and out of the LLM? We basically have LLM-driven, so the LLM decides, and those are typically better for conversational agents and chatbots. Code-driven, you can decide. You can basically do a pass on each round of a conversation and say, okay, I have some recipe of how to basically extract things that are important to me. So, for example, in a corporate environment, there might be a lot of opinions, let's say in a chat in Slack. But there's going to be opinions from, let's say, an architect or somebody that built a specific tool that might carry more weight than somebody else's opinion in there. So you have to remember all those things, but how do you rank them? In those type of metadata-driven extraction and ranking of memories or completely discarding of memories, it's very important in different environments. Specifically, things like that are basically very domain specific. So, I have to mention, obviously, there is a background processing thread story for all of these agentic memory servers. The idea is that you might have remembered something, but that memory might not be fully formed, might be incomplete, might have errors. So now you want to clean it up. You might want to summarize it. You might want to remove the things that are basically semantically drifting from the conversation. So how do you extract that in a clean way that can be reused later? And that typically can happen online all the time. Sometimes some processes have to have more processing time needed. Given LLMs, it still take in the number of seconds to basically reply. So you still have a lot of time to basically do things in parallel in a separate thread. But some things that are long-term, like connecting a multiple universe of memories into some sort of knowledge graph that can be used effectively later on, that it's definitely something that you want to do in a background thread. So for this demo, I have 6 memory types. We have semantic, episodic, procedural, and then we have some agentic types. So the first 3 are cognitive memory types, basically informed by psychology. And then the last 3 that I have in here, entity, workflow, and toolbox, are basically agentic specific, or computer science specific, basically, based on how we deal with things in our systems. So let's see basically first the system with memory and without memory. So in here, I'm turning off the memory of my system. It has a chat interface. I'm saying, hey, remember that my favorite color is something. And then we can see here that now if I ask what my favorite color is, it's not going to remember it. If I turn, so I'm here asking again, hey, do you remember what I just told you? And it said, nope, I don't know, because it's a new session. So now I'm going to enable the memories server, and it's going to use MCP to basically extract and store memories. So you can say, you can see that it says store a memory about that. I start a new session now, completely from 0, and I can ask what my favorite color is, and it's going to retrieve that. You can see there on the memory operations on the right that it's basically finding that memory in the system. So how does this happen? You have an extraction prompt, and you can basically be pretty blunt about what you want in here. It's like, hey, here's what you're doing. You're extracting semantic memories. Here's an example. Here's some contextual grounding requirements, like things like, for example, replace all pronouns with user. And then you bind that to the application user in the system. So now here it's another example. So I'm going to say, hey, I strongly prefer TypeScript over JavaScript for all backend services in some project named Phoenix. And now it's storing that memory. And you can see that it also did a search, but didn't find anything that was relevant to the conversation. And I'm noticing here, I'm saying, hey, and this is important, I have a severe peanut allergy. So it's storing that in the system. Then in a new session, I'm asking, hey, what language should I use for this new Phoenix microservice? And then now it knows that I prefer TypeScript over JavaScript. And it's going to say, hey, you probably should use this for the project. Then we have the episodic memory. So events and experiences, time-bound events, meetings, experiences of that sort. And we do basically a little bit of like a kind of regular expression type of management in here. If you see something that says next Thursday, well, the system knows the current date. So now I can basically create a concrete date and create almost like a calendar event. And remember, what's a calendar event? It's a memory. And I might be tainted by my work at Redis, but I see everything in agentic systems now as a memory. So for example, here, we have a continuation of that. So let's say, hey, last week we had a sprint planning for this system and with the tech lead, and we decided to prioritize the authentication refactoring for the project. And you can see here that, hey, I have a code review too for this Friday at 2 p.m. With the platform team. So I start a new session, and I can do something as simple as basically just asking, hey, what meetings do I have coming up? And it's going to basically search the memories. Notice they use a query for just meetings and use that to semantically find the right things. And now it's giving me a nice list of, hey, you have a code review on Friday, you have a sprint planning meeting. And obviously, I did this demo, I recorded this demo a while back, so you can see that it's from February. But so then entity memories, and here's where basically the line between vector database, relational database, and graph database blend. Ideally, you want to use a graph database for something like this because you have very smart algorithms to basically navigate to those graphs. But in this case, I use basically just a JSON set of documents with basically links between those documents. And in Redis, you can basically use things like Lua scripts to replicate graph algorithms that are good enough for the size of the graph that you're dealing with. So here's an entity memory. I can basically say, hey, Raj Patel is the tech lead on the project Phoenix. He reports to Lisa, which is the VP of engineering. And you can see now that it creates basically entity memories for each one of those persons. with the roles and everything. So basically, I can see, I can ask, what it knows about this, and it's bringing those entities. So this is very important when you are dealing with information in a corporate environment where there's basically hierarchies of users with different levels of expertise in importance or having the final word for something. So how do you basically consider opinions or basically take something that might be a mandate for something? In your memory system, using basically name entity relationships, it can create this graph that has basically metadata for all the importance of the different things. So you can see here, I asked, yes, go ahead.
This is a great
How are we doing?
But
thank
I
you.
would appreciate if you could wrap up because we are past.
I will. I'm sorry. So yeah, let me move near the end now. I think everybody's getting basically the idea of where this is going. And the last, let me do here okay, I think I can start right here. So again, at the end of the day, you want one of these memory services to integrate all those memories together and work in a holistic fashion. So in here, we have basically this cross-memory integration. And you can see that I can ask something that might bring a lot of different memories, put them together and give them to the LLM to reason about this. And you can see that it's basically remembering that I have a severe peanut allergy when I order this lunch for my team. So yeah, it's something that basically this long horizon of memory, it's very important. So again, memory, it's everything external to an LLM that's not taking knowledge. And how we manage that, it's incredibly important nowadays. Here's a little quote by Harrison Chase from LangChain. And again, the idea of memory, like he said, is tantalizing. And in my mind, agentic memory, it's basically the next evolution of context engineering because there's so many fine level details about this. So here are some of the lessons to walk away with. Memory is crucial. Designing your application memory system should be a primary activity. There are a few generic memory types, but you should think about memory types that are specific to your problem. And there should be a way to basically dictate how those are processed, extracted, and maintained over time. Thank you.
Right. Thank you so much, Brian. Let's welcome the next guest, Ad Burns, who will talk about application modernization. Can we have an ad on stage, please?
I'm ready here. Bruno, can you hear me? Hello.
All right. So, Ad, welcome on stage.
Thanks.
We just heard from Brian about memory. And one fascinating thing that clicked on me was in the physical world, we humans tend to get inspiration out of nature to do something like buildings, architecture,
birds and airplanes, right?
Exactly, right? But in the digital world, sounds like we are using the brain as inspiration. Is that right, Brian?
Yes, I would think so. I think that basically, I mean, the brain had billions of years of evolution to basically come up with something that works really well. And again, learning in our environment, it's about basically sensing and experimenting. And I think our agentic systems slowly need to move towards basically that kind of poking the environment, see what comes back, and turn those things into the proper memories. And then being able to assemble those in a way that our limited context windows can basically do some effective work with them.
So and you just said something interesting, like over billions of years, the brain has been modernizing itself. Is that how we can frame it?
Oh yeah, certainly. Basically, the cortex, the cerebral cortex, we can think of it as a supercomputer that it's basically laid over top of some kind of reptilian brain that was basically all about survival, which gives us the system to basically inspect the environment, get signals in, but then those cortical columns in your brain can basically build mini worlds about different things, and then how to combine those worlds into this mesh that you use for reasoning in real time. It's an impressive feat of engineering. In evolution got us there. So we take those lessons, and there's obviously places where software systems can do better than the brain in specific, very narrow domains. So hey, take the best lessons from the wetware, and take the best lessons from the hardware, and try to combine them in a synergistic way. Oh, I said synergy. That basically allow us to get the most out of our systems. And like Rod said in the prior session too, basically this continuous planning. Right now, we're basically hard coding, flows, and then we have specific agents doing things at every flow. Or we're basically, rolling a dice and saying, hey, here's a bunch of agents, and you guys figure it out. So this kind of planning type of environment with GOAP, I think it's also where the industry is going to slowly be moving towards, specifically for enterprise, because we want deterministic but robust and flexible systems. So that is a perfect combination of things.
All right. Well, Brian, thank you so much for your presentation. Thank you so much for your time. Great conversation. And see you next time. All right, Ed, stage is yours. You're going to talk about modernization with Copilot.
Yes, and I'm going to be excited to demonstrate the new front-end capabilities that we have in GitHub Copilot Modernization.
What application is fun without a front end, right?
Exactly. You can't do much.
All right, let's take it over.
And as people know, I have done a lot with front ends over the years. People might remember Java Server Faces. So that is something that I've worked on, and it's still out there, still being used actively. All right, let's take it away. Hi, I'm Ed Burns. Thanks for coming to my session today. I'm here to talk to you about modernizing a Java app with a Node front end with GitHub Copilot Modernization. First, a little bit about me. I've had the pleasure of working in the industry for over 30 years now, and had the front row seat at several transformations in our profession since 1994, from the client to the server to the cloud, and now to AI. Let's cover what modernization is. When we talk to customers, we hear the same patterns coming up again and again. And the challenges of modernization usually fall into a few big buckets. First, there's the security and compliance concerns that we see. So that's like 65% of the customers we talk to have that as their top concern. Second, there's the scarcity of tech resources, both in terms of quantity of developers they have and how thinly they're spread across modernization initiatives that happen in the enterprise. Let's face it, budgets are staying flat, and the workflow and amount of work to be done is increasing. So we have to turn to tools to increase automation to make things more possible and allow our developers to get more done with the existing headcount that they have. Finally, this legacy app architectures. These monolithic systems were designed decades ago when the cloud was not even thought of, or hopefully when the cloud was just emerging. So refactoring them takes time, expertise, and often needs a cultural shift. So it's one of the big reasons that programs slow down, is this struggling with monolithic application complexities. Well, we have some good news, though. With GitHub Modernization, you get end-to-end guidance, planning, and execution with agents across all of the phases of the lifecycle. You can click this link to see our full depth documentation about how to use this tool. And in our talk today, we're going to cover some deep dive on some of the features as well. So there's really three stages I want to bring to your attention today. The first, assess and plan the modernization journey. Second, accelerating your .NET and Java upgrades. And third, deploying directly to Azure with infrastructure as code. So developers can offload complex and time-consuming tasks to rapidly update and modernize their Java, Node.js, and .NET applications with GitHub Copilot. This tool can let you modernize at scale. So we have a modernization agent that lets you assess the application, plan application journeys, and execute with automated upgrades. You can customize, build your own custom skills that are built on your organization's IT practices, business logic, and software factory patterns. You can use the tool to automate Java, Node.js, and .NET upgrades. This lets you bring your language and framework versions up to speed. Many times, if you have an app that you haven't touched in 15 years or so, because it's been working fine, but you need to modernize it because it's time to move it to the cloud, for example, the first thing you have to do is pay down that technical debt and bring all of those dependencies up to the latest and secure versions. Finally, from streamlining end-to-end migration. So assessment to deployment, we simplify the migration journey with full visibility, control, and predictability while delivering higher quality outcomes. Now, we recognize that in this time of great upheaval in the industry, the surface areas where developers are interacting with the technologies are more diverse than they ever have been. So we meet developers where they are, whether with a terminal CLI, command line interface, cloud coding agent that is running inside of GitHub. We also, of course, have traditional IDE support for VS Code, Visual Studio, and IntelliJ IDEA. So let's look at some of the capabilities we have in the tool. We have assessment. It's really a built-in code assessment. You can also bring your own code assessment tool if you want. Doing code transformations. So there's lots of scenarios that we can cover from modernizing from one technology to another, one X to Y pair, as we like to call it. Of course, security is a super important aspect, and security is built in. So we do modernization and patching and CVE security checks. In agent mode, it can also fix these security issues, letting you review and approve changes as you go. Tests. This is the most important one in my observation. So when you get to testing, sufficient test coverage is the most important ingredient for a successful migration. That's because tests are the executable and deterministic expression of correct functionality in your app. And when we're doing modernization with large language models, repeatability is something that is not always a given, but if you have deterministic tests that must pass, it really helps the LLM to do a great job and make sure that what you end up with is in fact a correct manifestation of your application. Now, once you got things all modernized, you of course need to containerize it and deploy it out to the cloud. So with this effortless containerization, Copilot uses built-in containerization assistant that lets you generate those Docker files and containerize your app. And it lets you build out infrastructure as code technology to deploy it on a variety of Azure endpoints. Now, when you look at this slide, it looks super simple, right? So when you put it this way, the journey looks very straightforward. But each one of these points is a very complicated subsystem, each with its own unique and maybe even sometimes competing modernization objectives. So one way to let the simplicity of this straightforward journey actually shine through into your implementation is to apply the power of Copilot at each step. And that's what GitHub Copilot Modernization can do for you. Now we have two entry points that we want to bring to your attention. And I'll walk you through how organizations can accelerate application modernization using GitHub Copilot App Mod. The process is very simple but powerful, and it integrates seamlessly into your developer workflow. So first, on the left, the app owner/architect entry point. This is not sitting in front of an IDE, right? This is working with GitHub Issue Tracker, for example. So if you already know what app you want to modernize, you can start directly with the tool via the CLI. And if you don't have the tool handy, you can use build an assessment with Dr. Migrate, Cast, or even Azure Migrate. So any of these tools, including GitHub Copilot Modernization, will produce a report. But once the report is an assessment is complete, we just can't have those findings sitting in a report. The tool will automatically convert them into GitHub issues. And this means every modernization opportunity can be tracked and actionable within your existing developer workflow. Developers or agents then pick up the issues and start working on them in their own way. So if it's a human developer, maybe working on Visual Studio Code or VS or IntelliJ, but if, of course, if it's an AI agent, then it's picking up the tools and using the coding environment that you set up for it. So this is where GitHub Copilot App Modernization really shines. It analyzes code bases, flags dependencies, fixes bugs, and generates deployment files. But the focus of this talk today is not the app owner or architect entry point. I really want to dive down on the developer entry point. If you want to learn more about the architect and app owner entry point to the tool, please take a look at our GitHub Copilot Modernization ebook, which you can get by clicking on this link right there. And it'll give you a lot of great details and a lot more than we can cover in our little time that we have today. So let's look at developer entry point. For each of these steps, we show developer in the loop here. So we're taking the developer working on a per application basis, right? So we have 3 different applications, maybe a Java app, a .NET app, and maybe some other kind of app at the bottom. And they're all deploying to different services. They all have different sort of journeys, but they're all using the same tool. And the workflow is the same, regardless of what kind of app you're working on. So let's take a look at the 2 different experiences. On the left, we have the app owner architect experience in the GitHub website, for example, using GitHub issues and the GitHub coding agent. On the right, we have the IDE delivered experience there, and that's what we'll see in our demo that's coming right up. I also am happy to announce we have support for NPM-based front-end upgrades. So many Java applications will have a Node.js-based front-end, and this tool is able to deal with that and help you migrate those things. So dependency hell and unmaintained front ends can be a lot easier to work with, and we'll see what that's like in our demo here, going from TypeScript 3 to TypeScript 7, going from Angular 8 to Angular 21 in just a matter of minutes. Now, if you're using the version 1.15.3 and earlier of the tool, you have to make sure to set this experimental flag to true. That is going to be removed from public preview feature and just be always on in the next version of the GitHub Copilot Modernization that's being shipped right now. So in a week or so, you won't need to set this, but just in case you're using an older version, please take a look at that. Let's do the demo. So let's basically upgrade some random old sample app I found that has an Angular front end and a Spring Boot back end. Let's demonstrate the ability of GitHub Copilot Modernization to modernize a typical Java web app with a JavaScript-based front end. With the help of Copilot, I went out on the internet and found this excellent, fully self-contained application here, full stack Angular Spring Boot from Huari Zegai. And let's take a look at what it currently has on the front end. So I've got it cloned here locally. Let's CD to the CRM front end and do npm outdated. And you can see Angular core is very out of date. It's 8.2.14, latest is 21.2.7. The TypeScript itself goes from 3 to 6. So this is an out-of-date app. Let's take a look at the back end, and we'll do Maven, dependency tree. And okay, so this is Spring 2.1.7. So you can see it's pretty old. Let's run the app as it is just to demonstrate how it works. Okay, let's look at the front end here. Okay, we'll log in and we'll look at customers, and we see we've got a customer management system. That's the app, and let's now modernize it. Well, because we're going to modernize the front end and then the back end. CRM front end, code dot. And you can see I've got a nice button here that says upgrade NPM packages. Click that, and it's going to fire off our task. So there's the progress. You can see it's going to update it as it goes through dynamically. Right now, we're setting up the progress tracking. It's doing the precondition check. Next, it will do upgrade plan generation. There it is, set up version control. So here you can see what the plan is. Upgrade the packages in groups. So it did an analysis and generated a plan. Then it's going to do some validation and generate a summary. Okay, so now it's going to create the branch. It's going to start making commits on this branch. And you can see it's filling out the upgrades as it goes along. So we got TypeScript done, we've done types, Bootstrap, now we're doing TS Node. You can see now it is doing npx ng build. Okay, let's take a look at the summary. Angular 8 to Angular 21 plus TypeScript 7 migration result. So it gives you the status of all of those things and what it did to get there. And let's double check by going out and running npm outdated again. npm outdated. And you can see it's only returning one thing. So let's go back to the top level directory and do start demo. And open this again. Okay, there it is. Okay, customers. Let's stop this and we'll do the back end now. Stop. So cd crm rest code dot, and we'll just do upgrade Java runtime and frameworks. So here it did some analysis. I've got Spring Boot 217, Java 8. Okay, so now it's given us some choices, 17, 21. I'll just check the 17 one, looks good. Now it's moving on to step 4, upgrade to Spring Boot 3.5. Migrate JavaX to Jakarta and 3 affected files. Okay, you can see all upgrade goals met. Spring Boot 3.5, Java 17, and it did a CVE check. The CVE check verifies that there are no vulnerabilities that need to be mitigated. If there are some, it will fix them. And let's do start demo. Okay, let's sign in. There we go. Okay, credential error. Okay, so we had some authentication problems, but I asked Copilot to fix it. And it went through and it said it found the problem. There are 2 conflicting security filter chain beans. The fix is to disable the conflicting basic auth, rebuild the packages and restart. So let's see if it works. 4200. And we'll log in. Yes, and that worked. And we'll take a look at customers, and there they are. Now, the next step is to containerize the application. And there's a quick start for your use here. Containerize your project. And this is making use of the containerize application task, which I can show in the tool right here. Common tasks, we'll expand that. Let's look at containerize and do containerize application. And if we play this task, it will create and use the containerization assist MCP server developed by the Kubernetes team. Okay, so let's select the containerized application. This is from a different demo app. The first thing it will do after we select that is analyze the project, and then eventually we'll generate a Docker file. And this particular Docker file is for the other sample application that we have, but it's very similar because it has a Java backend and a lighter weight front end. And this Docker file is using the Tomcat Docker image. The next thing we'll do is select the Generate Infrastructure as Code and Provision button. We'll have a choice of several different Azure services to pick, from our world-class PaaS to our world-class AKS, and we will select AKS. Then it will generate a Azure Resources Architecture diagram. You can see we've got this nice architecture diagram here that shows the various services that we have and how they'll be deployed on Azure, given this Azure Resources list. And it's going to list out the execution steps that will happen when the provisioning is actually done. And the next thing you can see, it generates the Terraform infrastructure as code. So this TF file will deploy the Azure resources. There is the TF vars where you list your Azure subscription details and outputs, and it'll generate a script that invokes the Terraform deployment. Here we can see the deployment descriptor for the Kubernetes instance, and that is all you need. So you can see when we get to the bottom of the list here, we'll have another way for deploying the service. There's the service descriptor, and you can see to provision, install Terraform, and then just run the script.
Okay, so in the interest of time, I'm going to cut short the presentation a bit and just let you all know that you can see the replay of the full presentation there. So I'm just going to leave you with these getting started resources here. And the most important one I want to mention again is the ebook. I've dropped a link to the ebook in the chat. And you also really want to take advantage of the GHCP Modernization White Glove program. You can directly contact our PMs. They'll reach out to you and do some hands-on assistance with your modernization effort. And it's a great way. So with that, I will stop and turn it over to the next presentation.
Thank you so much, Ed. Let's welcome on stage Mary. Mary, are you around? Can we get you unmuted?
My mute. Okay.
There you go.
Hey, Ed, and hey, Bruno.
Hey, Mary. Good to see you.
Welcome, Mary. Ed, thank you so much for the presentation. Let's, in the interest of our time, let's move on to Mary's presentation right away. Thank you so much, Ed.
Yep.
Mary, stage is yours.
Thank you, Bruno. Okay, all right, folks. Let me quickly kind of switch some things around so you can see my screen. Okay, I understand we only have a short time, but I will be actually sharing with you my live stream, and also then we can actually get more into deeper talk too. But for now, just give you a taste of it. So this is building scalable multi-agentic AI systems in Java, and essentially orchestrating agents, right, using event-driven approach. So let me move forward. And this is the plan. Who's Mary? And demystifying Gen AI agentic architecture, the event-driven world. I feel there's just so much in this aspect that isn't being talked about. And I really would love to talk more about it and also kind of set the stage. So, and another aspect too, besides the event driven, is basically, it's all about data. So getting into distributed computing, agentic AI, data engineering, AI system design with CAP theorem. That's what I'll get a bit into. And then the event-driven approach, how can we kind of spot that opportunity to use it, right? For RAG, for agents and workflows, all of these things. And don't forget too, we always have Gen AI challenges and, share with you the resources. So really quickly, this is just a picture worth 1,000 words. I'm also a Java champion. I'm also an Oracle ACE associate, and I'm really passionate advocate inside of me, but I'm currently too helping out the AI Collective. If you are with the AI Collective, let me know too, maybe in the chat. If you want to join, I'll share with you. I'm the VP of the global team for Western Hemisphere. So all of America's North, South, Central. And I also help out with the Chicago chapter. Plus, I also help the Chicago Java users group as well. So these are kind of all the things I do. Again, I'm very reachable too. So I want to invite you to join me. So demystifying generative AI and agentic architecture. I want to kind of quickly point out, right? We all kind of look into AI. It's just everywhere. And also too, this conference is specifically about Java, and my route, as a developer, I worked, over 20 years in Java as a developer, software engineer, and then get into more architecture stuff. I feel that actually the crux of it, right, is essentially the data. Without data, there won't be any AI. And in fact, the world too lives a lot, it basically lives on data, so many things with it. And as you can see, right, data is what kind of drives and makes things happen. And let me kind of really quickly kind of bring this up. I actually, before, when I was back at IBM and working a lot too with event-driven systems, reactive systems, all of these things, I feel that somehow, right, with the current AI, we are kind of all excited and seeing what it can do. But actually, to me, right, I feel like we are like driving a car. We want speed. We want the result, get to places. But there are lots of things too that are not being talked about how. Of course, people seem to think that, well, let the AI do it. But we all know it's not true intelligence, so to speak, right? AGI isn't quite here yet, or ASI, essentially artificial super intelligence too. These things will take time to do it. And plus, how can we actually make, a robot, a machine to think like people, to kind of react like that? But anyway, getting back to what we need to do now is basically still we need to solve the problems. It's like, lifting up your hood of your car, how does it work? How can we make, the engine to be more efficient? And also not only that, let's say, if we compare it to a car, all these things, the gas, how does it flow through the system? And that's what I want to get into, the agentic way. We want to do things that are scalable, a car that can drive hundreds of miles, not just for a little bit, and which I think the current agentic era it's basically, it's doing fancy things. Don't get me wrong. The LLM is fancy. You can just ask it to do stuff. It can write your essays. Don't get me wrong. I think those are very good. But it's just that, we need to bring it to the next level, enterprise level. Maybe some of you are working with, big corporations doing big systems. We need to make it scalable. And then we rely on agent to do things. And we know that agent isn't like, something very new. But as such, that why we kind of rely on agents and look at it, right? LLM has its own limitations. There's not enough memory, probabilistic kind of results, from the algorithms of these model. And also it's opaque. You can't really add any attributions to the answers. And not only that, it's very expensive too. So how can we make it kind of better? So essentially too, right now, I think, again, in the world that we are living in with agents, that we are doing is mainly on this zero shot or one shot thing. You ask some question and it does the things very well for you. But again, in a complicated world, we have multiple steps. For example, even like doing an order entry, we know that it's not just with the order, it flows through the system and it has to kind of touch on the inventory system. It has to go to supply. It has to go to other ordering, parts. For example, you need to order something that relies other parts, other components, all of these things. So it's not, it's not very easy if we kind of do things kind of in a more, advanced kind of way. And not only that, scalability too, like in this kind of system, right? For example, like orders entry during like Valentine's Day, you're going to get a spike in all of the order entry. Those kind of things, can your agents handle it? So we want to kind of address that. Tasks are complex, there are workflows, data, we need to make sure data is consistent because data is flowing through different network boundaries too. Don't forget that, right? Those kind of things. And of course, there's also the talk of memory, right? Remembering the state on enterprise kind of level usages. So now let's take a quick look too into agentic architecture. So basically, structure and design of AI systems that leverage on AI agents to perform tasks, they need to do things autonomously, autonomous execution. And also too, not only that, but the agent itself is just kind of think of it like a traffic cop, it's like doing coordination. It needs some tools, it can't do everything. It needs to be able to call some tools to do certain things, their integration, all of these things, as I'm sure if you're already working with it, you already know. And not only that, right, scalability needs to be seamless too. If you get more order during, a high season, it needs to be able to handle all the orders. And not only that, right, one thing is resiliency. We know that, we don't live in a perfect world. There are problems that occur. We want systems to be able to bounce back, if something goes wrong. So key concepts, agentic architecture. It's basically, you can have vertical architecture, having one agent leading, kind of making decisions, all of these things, and allocating these tasks. But then you can also have horizontal architecture, in which you can have multiple agents, and which is usually the case too. We're not only using one agent, we're having multiple agents that are collaborating too. And not only that, there are also the orchestration piece. Think of like, for us, I can always think of like an orchestra playing music, and you have many different instruments and many different agents, likewise for an AI type of applications. And we need somebody to be able to orchestrate it, making sure there's they all kind of interacting in the proper way. You don't charge somebody until they enter an order, that type of stuff, right? We need to kind of take care of that too. And these task execution are complex. And also too, you want it to be able to make decision autonomously. It should be able to reason, and not only that, it should be able to learn. If there are things that it needs to learn, it needs to kind of figure that out, along the way too. So that's kind of like the key concepts, kind of adaptable, that type of stuff. And then ideally is that there shouldn't be even any need for humans to be interacting, kind of doing all that stuff. So let's get to the event-driven world. At the heart of AI is data, and the flow of data in many directions. So we kind of talk about event-driven architecture, architecture level, meaning that, we're no longer kind of relying on kind of the traditional way in which, maybe there are requests coming in. So the rest of the systems might be just sitting there waiting for the requests to come in, and then you start processing it. But for event-driven, it's basically, events come, and when it comes, we'll process it accordingly. There ought to be some ways of reacting to, certain actions or kind of triggers that trigger it, because there can be like commands that coming in, all of these things. Now, looking at the data too, data can also be in different states, right? So when we're talking about data at rest, it can be in a storage, in a database or file system, all of these things, or it can also be in transit. It's basically, you have data that's being extracted from database, from file system, that they need to be sent over to another system for further processing, for example. And of course, there can be data in use as well. Anytime too, we know that data gets extracted from a database and then it will be transformed. And there are certain things you need to calculate a total cost, for example, something like that too. And then there are also different techniques. We're talking about event streaming. And this is when data can be coming in at any time. There's no kind of like set way to say that, okay, you do it like, at a certain interval. It's basically any commands can come in at any time. And then also there are event messaging. These are techniques that we can handle when messages comes in. And now we can be talking about like a publish subscribe type of pattern, in which we, for example, like I'm quoting example here using in the Java world, especially, you can be using Apache Kafka or Apache Pulsar. There's also like other Red Panda, for example, or Solus. All of these are event kind of driven type of store, and it has mechanism of dealing with, like requests coming in. There are also backlog, for example, things like that. And all these things too, we have to be kind of thinking about those things, because once we handle messages coming in, we have to kind of figure it out, right? How do we trace it, track it, all of these things? And then there's also another technique is called event sourcing and CQRS. CQRS stands for Command Query Responsibility Segregation. So these are like basically we can have messages coming in, and instead of having one table storing the status of certain entity, let's say an order entry, instead of having just the status field, we actually want to track the change of the state of this order over time. And so the good thing about this is that then you'll be able to also kind of track, if there are problems with it, you need to go back in time, looking at, backtracking, all of these tracing, all of these things. You can do playback. If you say, okay, for example, I work at the Mercantile Exchange in Chicago before, high frequency trading, and we know that like say people try to do trading, they buy a stock, sell a stock, or actually futures and options. Things change really, really fast. So we want to be able to track any kind of actions at any time. So that will be perfect to using event sourcing, because then you don't only kind of keep track of that particular order in that particular time, but you kind of track it through time. Then you can do playback, all of these things too. So, okay, so those are just some of the techniques. And then we look into like Gen AI type of streaming usages. As you can see, right, just like anything else, Gen AI, we're using prompts through command line, through browser, through mobile app, all kinds that comes in. These are prompts that are, in streams of data coming in. And then essentially too, then we bring in like RAG, for example, that Gen AI intermediary steps, like a RAG operation, right? The RAG is essentially drawing data from external data sources to enhance your prompt. So for example, like database, file system sockets, and message queues, Kafka topic, all of these things, that also can be streamed in as well. And then from the RAG application itself, you modify the prompts, and then you send the enhanced prompts over to your LLM. That's another streaming that you can send over to your LLM as well. And then of course, LLM then will kind of have to figure out what the prompt is and interpret and send back the responses back to the RAG. So that's another like streaming type of usages too that we can think of. Now, using the event-driven approach, why is it so? But and as such, because data is very dynamic, right? The nature of it, the flow patterns, everything, you can do things asynchronously. There's no need for any, kind of a command processor to sit and wait. Essentially, commands come in, data comes in, it's asynchronous, through event streams, and we can process it right away. And not only that, all of these, receiver and sender components are all decoupled. So then if you need to scale it, then it will be much easier. For example, in a PubSub type of system, a broker, you can add more broker during times in which you get a lot of orders coming in. For example, you can have multiple brokers handle all of the, commands that comes in, and you don't need to wait around. So it helps with being very flexible and very scalable as well. And so in Gen AI type of application, you can have agents that, for example, one agent can be handling video kind of processing, and you interact with some LLM that's specific, right? For example, handling kind of video kind of model. The other could be dealing with text. The other could be handling audio, for example. So all of these things, and makes it more efficient. They kind of both go hand in hand, in my opinion, too. But the thing is, though, be aware of the challenge. All of these, because now you're having multiple components, it's just naturally becoming more difficult to debug, to track it. So therefore, your observability would need more work to kind of handle the flow of calls and the data it carries, all of these things, particularly in an enterprise type of apps. Okay, so now let me really, really quickly to step through. I know 5 minutes left, but CAP theorem. So I still want to touch on that. And if you are more coming from a distributed data side, you have heard of it. It stands for consistency, availability, and partitions tolerance. And as such, this theory basically say that of these three aspects of distributed data, only two are guaranteed at any time. So partitions tolerance is essentially pointing to network connection. So in a distributed world, we're talking about serious level of agentic apps, then of course you are dealing with a lot of network traffic, all of these things. So the thing is, though, we have to be prepared to, if there's network is down, then what do we do? Do we actually choose consistency, which means, the data has to be accurate, has to be most up to date. It is not old. However, in generative AI kind of scenario, I'm sure, everybody wants things fast, and especially ChatGPT, for example, things like that. We want data responses to be available. So in that case, it means that, well, we can sacrifice accuracy too. It's basically, it doesn't matter, if the data is a little bit off, that's okay, because again, it's based on the theory that there's this eventual consistency, so that when network comes back, the data will get updated accordingly. But it just takes a bit of time. So this kind of thing we need to kind of pay attention to. And why? Because if you are starting to get into doing serious agentic type of application, we have to think of this. And there are also different databases that have like different types of focus, right? Some are kind of built more for consistencies kind of thing. So they tend to be, maybe performance isn't as good. But whereas, there are some databases that are much faster, but then it relies on eventual consistency. So then it actually pays more attention to availability first. It's more responsive in that sense. But again, there are different types of database. So that kind of makes sense to that you need to, especially if you're, say, working with AI stuff, you need to pay attention to this aspect. Now, one more thing is I kind of also read about this only a week ago. This AI system design has got a new CAP definition. I thought it would be fun to kind of bring this up. A CAP theorem, but what it stands for is basically cost and accuracy and performance. So essentially, too, we know, agentic AI, or actually even ChatGPT, is very costly. It costs a lot of money. So the thing is, do you kind of like pay attention to more cost, or, like you cost more? Of course, you can also like have better performance. You want it faster, but yet same thing, right? Accuracy, it could suffer too. It's kind of same thing. So I just kind of want to point out, plus I'm also sharing the link of this particular article that was written by this person, Kashi, from Hexaview Technologies. I thought it's kind of interesting too, although it's got a different spin, not so much technical level, a bit more on the business kind of product level, I'd say. So, okay, so that's what it is. And there's also another thing called Parcel. Then that's basically an extension to CAP theorem as well. But I don't want to get into all this stuff now because I realize I don't have enough time. So essentially for Gen AI, so basically the thing is the else part, right? If there's no concern of network partitions, right? There's no network problem, we still need to pick between latency or consistency too. So that kind of thing. And so, but for Gen AI type of application is basically the else part will dominate, meaning that we still want, kind of like the latency to be very low, yeah, that's right, low. So high frequency. So think of it like that. It's more responsive, and that's what it is. So. Okay, so enough kind of theory. There's also CQRS. I mentioned too a little bit too about agentic AI. I think it will come into play because we're now talking about, all of these event sourcing type of activities. You want to separate out the read and the write. So then you make it more efficient too. So that's kind of the thing. Now, I won't get into all the details, but join my live stream. We'll talk more about it. And then also then I'll quickly kind of step through the RAG. And RAG, I think a lot of folks, if you're working with Gen AI, you know that RAG is kind of the de facto standard. So basically LLM is not trained with the most updated data. So we need to, in some ways, feed in updated stuff or last minute things or private data from your company, all these things. So essentially retrieval model and generative model. So that's RAG, right? So without getting all the details, there's a quick kind of flow showing you is that, their user adding a prompt and getting to a RAG application. The RAG will then kind of talk to a vector database, for example, and get data from some external source like the a Kafka topic, for example, and then it will use that data and enhance the prompt and send it to the LLM. The reason is that this way you get more private data that's not exposed in a public LLM, or you also can get data that's kind of come in at the last minute, again very up to date too. So that type of stuff, you see that there's a lot of streaming type of usages that can happen as well. So all right, let me see. I think I might only have like 2 minutes. So really, really fast, getting into like agents and agentic, right? So agents is basically the one who is authorized to act for or in place of another. It's a computer application designed to automate certain tasks. And agentic, being agentic is basically, taking in all of these characteristics. And one big kind of thing about it, it needs to be very, very adaptive too. And it's not just like I'm doing things, it needs to be adapting to the situation. And that's kind of like the ideal type of situation. It should be able to orchestrate as well. There are complex workflows. It's not like anybody can do anything, but needs somebody kind of overseeing, making sure one part is not overpowering the other, making sure everything can work together nicely too, and everything is coordinated, being able to process all the logic and evaluate answers as well. Now, multi-agentic systems, essentially, you can have multiple autonomous agents like working together, and they each specialize in different tasks. And it's basically too, you have one maybe like a more like a ruling kind of think of it like a project manager coming in and kind of manage, divide up complex tasks into manageable subtasks too. And it's basically too, you can also have agents. They ought to be able to figure out if they don't have the answers, they should be able to go to another agent and ask for the answer. They should know too. So for example, an orchestrator agent ought to be able to kind of help in that sense too. Okay, so there's just real quickly, there are also like model context protocol that helps, with some of these, connections that you need to make, to work with resources, lower level resources, databases, tools, all of these things is from Anthropic, MCP, we already know. And then there's also A2A protocol, which is for agent to agent type of interaction as well. But the thing is though, let's look at these, right? These two protocols, again, I just want to kind of quickly point out from an agentic point of view, you can look at, MCP's more lower level, deal with APIs, enterprise level applications, but between the agents, they can use A2A to communicate with each other as well. Okay, so all of these things, perhaps I won't get into all the details because then it's kind of, but I have this slide deck that I can share with you. It's just some ideas of the type of agent types, event types that you can be using, right? There are certain things, but of course there are different use case scenarios. You can have different types of events to kind of be there to handle things. And this particular one is AutoGen. It's a Microsoft free software, right? That actually helps with developing agents in a conversational type of way. So I also have the link to the archive.org for this paper as well. So if you want to kind of reference that, it's there. There are also agentic design patterns as well. There are reflection, tool use, planning, and multi-agent kind of collaboration, and as well as like agentic orchestrator design patterns as well. So just really quickly kind of point out perhaps just additional information right now. You can have orchestrator, worker, that's in which a central agent will decomposes, I talked about it earlier, decomposes the task and delegates the subtasks to specialized worker agents, and then aggregates and validates result is orchestrator. And then the other could be hierarchical agent too. They all kind of organize in different layers too. Their manager, specialist, executor, all of these things too. Again, kind of have this kind of orchestrating kind of hierarchy to it. And then there's also Blackboard kind of agent in which the agents will contribute to and basically have a shared Blackboard. And it's a bit more like everybody is the same kind of thing, but it's more loosely coupled and it's an event-driven type of collaborative type of approach. Everybody having the same kind of power, so to speak, right, to kind of for your particular task. And then one more is basically market-based. It's basically agents can be autonomous participants that will actually negotiate and bid and compete for the task as well. So that's kind of called a market-based. It's a bit kind of newer concept, but I thought I'd share with you as well. So okay, so I think I maybe not have as much time now, and so I will kind of skip through kind of these in details about the reflection, tool use, and planning, and multi-agent collaboration. But there are some of these multi-agentic libraries that you can use to AutoGen, from Microsoft, open source and or free, and also Crew AI, LangGraph, and Strands, Agent SDK from Google. All of these two, these are example of that. And then there are also a couple of code examples I'm sharing in here. And for Java, there's also one this particular link too for this GitHub. I thought maybe you'll find it useful to kind of take a look at how an implementation can be done. And of course, too, I also have. Let me go back there. Okay. All right. So just really quickly too, I know I'm kind of going through so fast, but basically just be aware, right? Working with agents, working, all of these things, event driven is basically, agent memory too, context management, that aspect too is complex as well. You have to also like coordinate and ensuring data consistency again, across all network boundaries. And also these agents are distributed. Anytime when we deal with distributed, it's never very easy. We all know it. And then we also have to handle failures and partial results. It's not just like doing something. And what if things don't work? You need to be able to go back and fix all the steps as well. And as well as also handling latency and resource usage. And also too, don't forget, sustainability issue is still a big thing with these large language models. It's not very eco-friendly too. It burns a lot of energy. The data center is getting hotter. All of these things. So all of these are very intensive use of energy as well. And then of course, the Gen AI models, they are non-deterministic. So there's still hallucinations, although I think the issue is getting better now. And then also one more thing is essentially AI safety and responsibility. So responsible AI ethics, all of these things. And I actually have had one of my meetup, I have a mom who said that her son, an autistic son, actually was relying too much on, using AI and then was kind of causing problems too. So those kind of things, let's kind of also make sure, build in the proper guardrails and help people. After all, it is a tool for helping people, not to make our lives more miserable. Okay, so these are like the end of it, and if of this presentation, but it doesn't mean it's the end. But if you want, please connect with me. And this is my slide deck, and I also have my information as to how you can get a hold of me, my LinkedIn profile, my X profile, and also I have a Discord server as well. So please feel free to reach out, and I'm on LinkedIn as well, and I'm very reachable. So. And some of these two are the different things, and also my live stream. This is what it is. So if you connect with me, I'm going to start running some stream to talk more about the examples. I'll go more into showing code too in there. Okay, so thank you very much, and thank you so much again. I know Bruno, you kind of show up. Yeah, thank you. Yeah. Okay.
I was just sneaking in. Yes, Mary, thank you so much. This is a book of everything developers should know about agentic AI.
Yeah.
And I love it because, I mean, of course, we can't cover in details everything that you listed, everything that you talked about in a 25, 30-minute presentation. I don't think even a day is enough to cover everything, right?
Yeah.
But it's so amazing to see the amount of resources already available for developers to learn, to invest and evolve together with the new capabilities that are available now for software development and software architecture. So thank you for sharing that.
Yeah, thank you.
I'd like to welcome Daniel from Red Hat on stage as well.
Daniel.
So,
hey, Daniel.
Hi, everybody. Hey, Bruno. Hey, Mary. It's great to see you.
Yeah, good to see you too. Thanks for joining JDConf. I mean, Mary provided like an overflow of information for viewers and developers that can then go later and dig into each and every.
I just watched that. She really saved my lot of time.
Thank you.
It is a great compilation of resources, and I think that is what developers need at the end of the day. I mean, we can't spend every minute watching videos, right? We have to find, okay, give me the hints, give me the resources that I can, and then I can decide on my own where to go and learn. So that's why I love that compilation.
Absolutely.
Thank you.
All right, Mary, thank you so much. Enjoy the rest of your day.
Thank you. Thank you both. And yeah, good luck. And thank you. Okay, bye-bye.
All right, so Daniel, you will be talking about one of the things that Mary said during her entire presentation.
Yeah, I'm going to give it to try more like some kind of application example based on the tons of the Mary's like a more conceptual and academical things. Yeah.
Awesome. All right, let's get into it. Welcome.
Sure. Thanks, Bruno. Okay. I think so. I already shared my screen. Can you see my screen? Okay. Okay. Sounds good. Okay. Hello, everybody, and keep watching, and thanks for joining this session. So I'm going to talk a little bit about how do you evolve your from like a cloud-native application into AI-native application using a real example with like a Java framework, which is the Quarkus, and like a model context protocol, and then specifically we're going to use the bunch of the AI resources and capability on Microsoft Azure as well. So my name is Daniel. I'm actually at IBM right now. So most Java champion and Java people actually transfer IBM like 8 months ago and specialized this bunch of stuff. And here's my contribution and like a Microsoft MVP and Java champion. So you can reach out to me like a bunch of social media, and you can actually Google me if you want any question about that. And I'm living in Boston, by the way. So thanks to Mary in the previous session, she actually talked about great things about AI and capability, how Java developer build their own like agentic AI and generative AI and so on. So I'm going to just keep in mind that thing. So how do you actually ship it to AI native from cloud native? So AI application is require heavy workload, but your runtime shouldn't be, because if you have a heavy runtime like a for Java framework, and then you probably have a big challenge to consume your resources we complete with some your platform engineer or AI engineers team. So whenever you go with AI application development and build a new stack, you make sure to use a lightweight and a fast runtime for your Java application. For example, Quarkus gives some like ideal runtime, integrate with the AI application and AI model like LLM with the low footprint and fast startup time. And the AI application is not just coding API; it has some kind of like a complicated context to act like a human being, like a behavior, like a you and person. So with that, your new AI Java framework can understand your semantic context, but also it keep showing and providing you like a fast iterative process, the writing application and the test code and the build code and the back to the application and adding some new capabilities, something like that. And then this is kind of some common capability and characteristic when you stand up new Java application with your AI implementation as well. And then in the reality, when you build new agentic or even some general AI services, you probably connect to your existing resources, which is like a data resources, like a database or third-party API tool. That's the reason why MCP you require. So I'm pretty sure you already understand why you need to think about MCP from previous session, like a Mary session. But just to keep in mind that the MCP is just like a transport layer between intelligence layer, which is AI model most likely, and the other side, your like a tools, like a database, broker, or some other stuff. It's just transport layer. So sometimes you want to make your application more agentic stuff, like autonomous thing, but MCP is not mandatory all the time, because MCP is a maybe great tool to make a more standard way communicate your external tools. The problem is here, so MCP requires a bunch of the token and then more network hopping and loops, and it will cause some of the network latency or some of the more like your budget thing to have more tokens. But with that, still you got a great like a benefit from MCP, make an autonomous agentic AI system as well. But luckily, if you're already familiar with, or even you were already using Azure Cloud, Azure, Microsoft Azure already provide a bunch of the MCP server. When you go to public MCP report from Azure, you can find more than 5,000 MCP servers today. But in terms of discoverability standpoint, it's not easy to find the relevant and the perfect MCP server for your new agentic AI application. So Azure MCP server is a great like a place if you already have some cloud resources on Azure, which you already connect to your existing Azure resources, like for example, database or some of the customer DB without additional app or how to connect to that resource using like some program language based on SDK, API, or credential, and so on. So here's just some of the recommended architecture when you stand up like Agentic AI application system using Java and some of the Azure OpenAI, one of the AI model, and also some of the existing Azure resources, for example, database. So we're using Azure MCP server. So it will allow you make less code and pretty much quickly, easily access to some resources from Azure Cloud. So why you need to consider about Azure OpenAI rather than other AI platform like OpenAI directly or Google Gemini or even your local Llama. So I'm not saying Azure OpenAI always the best and any other stuff, but there are some good thing in case you're already using some of your application running on Azure Cloud and some of the external resources are running on Azure Cloud for database, messaging broker, or serverless, or some of the containerized application on top of that already. In case Azure OpenAI allow you quickly integrate with the data tooling, communicate that existing resources and including application, but also it provide the enterprise-ready and great capability how to guardrail your AI model between your AI model and your agentic AI application, and also how to fastly scalable your application based on AI workload as well. So let me jump into the demo and how things put together and it works for your AI application. Here's my quick demo scenario today. So basically, I'm going to try to use Quarkus in the live coding, which means I'm going to run my Quarkus application on my local environment. And then I'm going to just put in a simple configuration in my application property, because Quarkus actually provide two great stuff for developer productivity. One is a multi-declarative API, which means most likely developer just need to annotation, which is the easiest way, like a CDI injection, and then specify your capability with some external libraries. And then I'm going to try to put some user prompt that try to access some database already running on Azure Cloud. And rather than implement a known way, a known practice, how to connect to database using some Azure SDK or PostSQL SDK or some of the API or credential setting almost thing. Rather than I just use Azure MCP server, connect to that. There's actually trade-off, pros and cons. I'm going to just bring that up. And here's my Daniel030, my old social media handler, all my info, Daniel030, because there are many Daniel around the world. That's why I ended up with the number 30. Anyway, so you can go to this repo and then the JDConf AI native repo. You can actually pull and then give it a try on your local machine. But also, if you have any kind of issue or question, feel free to create a pull request or create an issue. I'm more than happy to address that. Alrighty. So here is my Azure database. So I already provisioned to save my demo time today. I have very limited time. So here's my database, like a customer dash, some Visual Studio PS kind of stuff. Here's my contact information and password I hide it. So this is like a PostSQL URL and username, password, something like that, and port. So here's my Cloud Shell and at the bottom. So I already insert some of the data, like a name and like a city. So if I just like a SQL command line, like a select from all data the customer tables, and as you can see here, so Daniel from Boston and Justin from New York City and Jenny from San Francisco. So just a quick simple some for demo table database. And then here is I already deployed the cheapest model GPT-4 Mini on Azure OpenAI. As you can see here, so this is a AI platform on Azure, like a Microsoft Foundry, and I create my workspace, and then I just deploy. I can actually deploy multi-model for specific purposes, like image generation or text generation, code generation. But in this demo, I just need to just small model like a GPT-4 Mini, And if I ask, this is a great thing, I actually quickly do a sanity check for this model working after deployment. So I just ask, what is a Quarkus? And the Quarkus give us some like a developer experience, GraalVM support, and React programming, and a Microsoft's architecture, and among other extensive systems. So if I ask, if still this model is working, I'm going to ask, what is Quarkus AI? If I add sending to here, and then it takes a few time just to answer like some Quarkus AI, which is most likely integrate with the LangChain Pose. So when I show the Quarkus AI with the LangChain Pose and among other integration, for example, when I go to here's my local environment, my IDE, and then by the way, when you go to this repo, keep in mind that here's all kinds of stuff you can actually replicate on your local machine, something like that. Okay, so my IDE, as you can see, this is like a Maven project. You can actually create like a Gradle project if you prefer more. And so here's some of the required dependency. I'm going to use LangChain Pose, Azure OpenAI, and you can actually use other AI platform, OpenAI or Gemini, local Llama, and among others. And then I'm going to using the MCP, LangChain Pose MCP library as well to connect to MCP server running on running on my local machine. And then here's some other like testing and CDR injection and like a reactive engine, something like that. That's it. Pretty simple. And when I go to resources here, and then first the configuration is how to access OpenAI, which is like a configuration pattern. So here's all like a credential API key, and then like which model I'm going to use that. This is just specified from like a AI platform. If you connect to platform like OpenAI or Google Gemini, it should be a little bit different, but pretty much the same key and values. And then I wanted to see all tracking like responsive guest model logs as well, and like a little bit timeout stuff. And here's the MCP configuration. So MCP provide the language agnostic capability by default, and then they provide Java like a JDK, Java SDK, JavaScript SDK, and Python as well. And with that, when you use the pure LangChain Pose, one of the common questions for me whenever I show Quarkus LangChain Pose, because hey Daniel, what is the key difference between just Quarkus LangChain Pose integration versus a pure LangChain Pose, including MCP or A2A among others? So you can actually go to directly that community project and use that. But in order to use that library into your Java project, you have to do some known step like a 1, 2, 3, and ABC, X, Y, Z. And the Quarkus, when Quarkus integrate into framework, and we provide more developer productivity, which means you just use like a declarative API, like annotation, CDI injection, an easy way develop application, like keep using live coding and less code, and putting the more explicitly key and value in the configuration property or YAML file. And MCP, there are 2 different ways to start your MCP server to access to external resources. One is you can actually running your MCP server locally using like a standard IO process, or you can access the remote MCP server that should be running on somewhere out there, like running on Azure Cloud, running on somewhere. Just access that MCP server using like a HTTPS URL, something like that, using with your credential, just like when you use AI model, exactly pretty much the same thing. So I'm going to use the great thing is Quarkus for like a productivity for developers. I just said like a transport type, which is a standard IO, and then here's my command line. So when you go to MCP public repo by entropy, and then you can find more than a couple of thousand MCP server available today. And then whenever you select most of them, and then there are some really fun how to install or how to start this MCP server on my machine, it most likely like a Node.js npm package command line. So when you set up this npm, like npx command line on application property on Quarkus, the Quarkus framework automatically start this process inside your machine along with your JVM, which is quickly easy. You don't need to have you don't need to do any other program code or application code to stand up this MCP stuff. And of course, there are some MCP configuration about relevant to tools, which is your Azure database, because I put on some of the requirement mandatory values, like a resource group, server, database, user, and host type, password, etc. This is like a known practice. So whenever you access any resource on Azure Cloud, you have to pass down this kind of mandatory environment variable as well. And then my Java application pretty much is simple. So this is you say that there are less than 10 lines of code. So the register AI services actually came from LangChain Pose, and then like an annotation circle, just to make this one annotation around my plain Java interface as like AI services, and then it allows another two annotation system message, and then like a user message is allow me to specify the user prompt and the system prompt. System prompt is the initial message sending to AI model at the start, which means when this application start. So this is like a specify behave or score or some of the characteristics on AI model. So my system message, as you can see here, you are helpful Azure Assistant with the access to Azure PostSQL database, and then use available tools. I'm not saying specific tool name, just say, okay, you can use any available tool. That is something like a Agentic AI capability, autonomously pick up the tool and then use the model, something like that, and then manage their PostSQL data and answer questions directly and concisely. And then here's another annotation MCP toolbox with the key Azure-RG, which is a resource group. That's why when I go back to property, you can see that here's the key. So if you have a multi-MCP tools, you can actually separate and differentiate it based on this key, like Azure XYZ or some of the your own ABC. This is a key and unique name, something like that. And then here's another like a tools. I'm gonna say this one why I uploaded that thing, but I did not put this on my application. This all. So let me try to run the Quarkus demo. It's allowing me like a live coding capability. Whenever I change something on my local application, it wire in a second compile, rebuild, restart. So my application is already start. And then when I just go to dev UI, from my local environment, and you can see a bunch of the visualization cards showing to represent what kind of library capability you're already pulling down your local file system. And here's a LangChain Pose here. And then we have one agent, it's a custom agent. And then we don't have any like normal function tools, only MCP. And the one great thing is Quarkus actually provide the web UI. You don't need to even spend time asking AI code assistant tool, or you can read some blog post to create like a fancy front-end application to verify your agentic AI application or generate AI services. Because Quarkus already provided, you don't need to focus on developing the backend AI application. So you can upload the message here, or you can start a new conversation. And this is your system message, just like we saw in my Java class. You can actually change that, immediately go to setting, if you change that, and then when you start new conversation, and that system message is changing, but not changing your local file system, your source code, only changing this web UI. And if I say like let's try to get all customer data from Azure PostgreSQL. So if I return and go back to my environment, and then it literally connect to Azure OpenAI, and then this is MCP low, so you don't need to worry about the error. This is like some just key, but it's not error, just tracing low, and then like a debug stuff. And you can see that Azure MCP server transport received. In the meantime, when I open the activity monitor on what process actually running on, you can see that npm actually process. This is MCP, my local environment. When I call this prompt, and the Quarkus automatically start this MCP. When I stop my Quarkus demo, this MCP server will be terminated automatically at a time. So there are many conversation function calling from MCP. And here's the, when I go back to UI, you can see that, oh, so this all environment variable actually pass down MCP server. And now MCP server try to connect to Azure PostSQL. And then PostSQL ask again, I need to actual the relevant variable. I already passed down MCP server get that one, and then passing try to Azure Cloud, Azure PostSQL, but they actually didn't work well based on like a Azure PostSQL like a credential design, more security kind of stuff. So so with that, you can actually several alternative ways to solve the problem. I'm not going to go into that detail as a demo, but one of the things is when I go back to here, and you can actually set another tool, something like Azure Compute tool. You can actually pass down directly all resource parameter for Azure database, and then put in the back to the AI services, and then you can actually set something like a tools and Azure Cloud Tool class, something like that. And then, or you can actually use another public PostSQL MCP server as well. And then without changing anything, I can actually pass down some of the parameter during my application here. So if I say with some necessary some kind of stuff, or you can put in that thing into your system message as well. So there are some ongoing effort to make it better, improve the developer experience as well. But today, this is kind of some like a little bit more security harness as well. So now I got some exactly same result, just like I did directly query in the Azure Cloud on my Cloud Shell. So this is a pretty simple demo and how it come together. Like Quarkus add your Java framework to build new AI native application, but also it using MCP, specifically Azure MCP server. Azure MCP server actually gives some a lot of MCP server, like some category, and then provide and allow you to access many Azure resources, like a cloud resources, which is maybe best practice. So as long as you're already using some of the Azure cloud and so on. And then I'm going to try to just to wrap it up. And then here's some of the practice and tips. So whenever you build AI native application, specifically Java, just always keep in mind that how to optimize your application, because AI application at some point in the future could be high scalable, just like you have a 10,000 microservice application on the cloud, specifically Kubernetes. So like a GraalVM native Scalable, which is a great way to make it smaller, faster. Even your agent application related to a specific model, could be a large model, could be a small model, and then that with that like a small memory footprint, and then containerize it as well. So if you keep deploying this architecture stack on the Azure cloud, you can have multiple choices for your container environment, like Azure Kubernetes services or Azure container application with some Quarkus and GraalVM native integration. This is one of the great things for memory footprint and also scalability. And one thing, last thing is in the production, whenever you deploy AI native application with Java, the application should be monitored and observed just like any other application in the production. So even if you got some problem or failure, you probably hard time to figure it out. So what is the problem? Is it from AI model or MCP server or MCP client or even agentic AI application? That's why you prompt somebody like observability capability, something like OpenTelemetry and micro profile metrics or something like that. And then of course you have a print some like a configuration to managing your AI model access quarter. So you don't want to read any AI application to access like a more than millions time to access a model. Of course, you have some like a governance capability. How do you secure and guardrail for your whole application as well? So I'm gonna just quick thing. So today, hopefully you enjoyed this session and demo. And then using like a Quarkus as Java framework for your next generation AI native application, and then not only Quarkus, but also combined with like an MCP, or you can actually add on AWA, like Mary said, or TCP AI services, and then like some Azure AI platform as well. Gonna be a great chance to build your own AI native stack. And here's some call to action. So you combine some like a hands-on experience, their documentation or Quarkus AI hands-on for free. And then you can actually go to like the Microsoft MCP GitHub URL, which you provide a bunch of the MCP server. And then for Quarkus, if you have any question about technical issue about AI and among other the general stuff, yeah, please join the Zuri chat, and then we are more than happy to address. I will be there too. That's it. Thank you so much, everybody. And then please feel free to reach out to me if you have any question after that. I'm happy to address. I'm gonna hand it back to Bruno.
Great talk, Daniel. Thank you so much. I loved your use of the Microsoft MCP servers. I was just looking at that repo yesterday, and it was, to me, like, I remember when I joined Microsoft 8 years ago, and as soon as I joined, one Java champion reached out to me and said, hey, Bruno, do you know how I can use Microsoft Graph SDK to send emails on Outlook? And I'm like, I didn't even know we had an SDK to integrate it with Outlook and Office 365. And then yesterday I was looking at the MCP servers, and it's a lot easier to use the MCP to integrate with Office and Outlook and things like that. And just having the LLM figure that out for us is so amazing, right? There's no need for an application to have SDKs for every single little thing. All we need to do is provide the tools, the MCP tools.
Yeah, absolutely. So the Microsoft has a great like a material and documentation. You can find that thing. But problem is sometimes, where can I find the relevant documentation to develop this kind of like Azure resources? And then MCP is a great tool. You don't need to spend time just to read LLM to find the better way, shortest way, and then access that tools.
Exactly. I also loved your demo showing the AI Foundry. And one thing that I may have missed that part, but one thing that developers can do on AI Foundry dashboard is actually trigger the same prompt with the same data and then compare different models. And they can easily see how the prompt will behave on different models, and also the cost. I mean, how many tokens, the speed, the process, etc. So they can be better informed of which model to use for what task as they build their applications that are multi-models.
Yeah, I love that feature too. It's give me some how to save my money for that.
All right, so let's welcome on stage Basil Rahman, that will be talking about building LLM applications like you did, Daniel, but he will be focused more on LangChain4j. And if I understand correctly, Quarkus has very strong integration with LangChain4j. Is that correct?
Yeah, that is correct. Yeah, that is correct.
I'm going to use Spring pretty much for this demo.
Well, I'm happy to accept the challenge for that.
that shows the diversity of the Java ecosystem, and it shows that if a developer already has a Spring application, they can embed LLMs using LangChain4j or Spring AI. If they already have a Quarkus application, they can integrate with LangChain4j and other SDKs as well. So I think it's nice to see both worlds right here colliding, but also collaborating in bringing intelligent capabilities for the Java ecosystem. So Daniel, thank you so much for your time, and we'll see you next time.
Great, and have a great days. Talk to you soon. Bye.
All right, Daniel. Thank you. All right, Basil, welcome to JDConf. This is your first time at JDConf, I believe. Is that correct?
No, I presented the last year as well.
Oh, there you go. So it's the second time. Lovely. So I would like to please just introduce yourself quickly, and then let's just dive into it.
Sure. So you know my name. I'm Basil, and I'm a Java champion, and I'm currently working in a company called Hammerspace as a senior staff software engineer. I'm a community guy. You'll pretty much find me anywhere in the Java community, like conferences, Java user groups. I also founded a Java user group back in Bangladesh, where I do run conferences, talks, all those things. Apart from those, I'm also a writer. I write content, blogs, and I published a book called Modern Concurrency in Java from O'Reilly. So yeah, that's pretty much extreme high-level version of me.
All right, so let's just get started with your presentation. Well, feel free.
All right. So hello everyone. Welcome to my presentation. As you can see, I'm going to present building LLM apps in Java with LangChain 4j. So what I'm not gonna do over here is that I'm not gonna expand on what LLM is and how LangChain 4j works at the basic level, because I understand it pretty much by now. Everyone knows what it is. So instead of that, what I want to is get straight to the into something more practical. So this talk is really about what happens after the demo. So it's going to be a demo driven, but at the same time I'll speak some aspect what happens, what makes a application production readiness, essentially. What thing can what are the things that can goes wrong in the in the production, essentially. So what are the things we need to consider, think about it. So let's start with the first basic demo, and then I'll get into those stuff. So this is a applications that I'm running on my local machine. It's pretty modular applications. It has pretty much all the aspect. App is essentially the main part of the applications, and then it has domain, observability part, RAG tools, and other things. But I'm not gonna start all of them at once. I'm gonna start gradually one by one. So the idea is I'll start from the basic and then add additional feature on top of it. So I have implemented it in a way so that I can toggle the feature by using feature flag, so that demo is smooth. I'll share the source code with all of you, so you can look into how I prepared this demo in a source code level. But for the very first things, that what I'm gonna do is, it's a basic chat. Let's say you have a tech store, you have a business. It can you want to interact with your customer wants to interact with this store, essentially. So it can communicate with the clients with informations they need. So for example, I want to order something, like I can ask, hey, what is the order of that particular, right? So for the first version, it's a naive LLM. It just my Java application connected to the LLM. It doesn't have any intelligence, any business context of our application. It just a plain communications between my applications and the LLMs. So what I will do is I'll just ask, hey, what can you do for me? Let's see what it returns. So essentially, I'm using here is OpenAI model to communicate. So as you can see, it returns, hey, I can assist you with order status, product information, pricing, etc., etc. So now, if I ask, where's the order, right? So if I click on that over here, and let's see what it returns. So it says, I'll check the order status of that order number, but currently I haven't enabled anything. For example, it doesn't have RAG tools, anything, but still it's sort of hallucinating, right? It says I'll check. So it sort of knows, it sort of tries to know things, but it doesn't know. So we need to provide some context to it. So for example, if I ask this, what is the ESC, Canada return policy of the headphone, right? If I send this information, as you can see, it says it's basically hallucinating. My business might have a different policy, but it's giving me a random idea. So that's it's working nice. It's communicating. I'm getting something out of the chat box, but then the information are not accurate. So that's why we need something integrated. For example, RAG, right? So that's where we have a corpus of our policy data that we're going to feed into the LLM, so that LLM can provide a accurate answer. Anyway, so moving on. So far, I feel like this particular chat, it's working. So I have a new nice interface, and as a user, I can type and I can get some results. So that looks really great. So now the next thing that since we have see this demo, so far it looks good, but now let's open the Pandora box recently, where things can start go wrong, right? For example, I have demonstrated of hallucination and bad retrieval. I mean, it doesn't know what's the business context. So basically, when we don't have all those information, the model guesses, and poor retrieval makes that even worse, right? LLM do not know your business policies. That's something you have to provide. So I'm assuming you are already familiar with RAG, right? Retrieval augmented generation. You provide a corpus of knowledge to give to the model some context, and LangChain 4J and retrieve those relevant chunk based on user questions. And I have over here a module already that actually does all of those things. Over here, as you can see, I have a policy corpus in this source repository for the demo. I have created all of this, using the ChatGPT. So these are not real data, but you get the idea. So for example, over here, CA, the return policy over here, as you can see, open headphone may be returned 21 days, but in the over here, as you can see, it says 20 days, which is also mentioned 30 days. So this is not accurate information. So that's why we're going to enable reg over here as we go along. And then so that's how we are going to correct the hallucination and retrieval. So we can also tune the temperature as well. Then there's a thing. So second thing is tool misuse. Essentially, that's essentially happens in production environment. The model may choose the wrong wrong operation, and that's a problem. So this is where tool design matters. Sometimes one tool end up doing a lot, and sometimes if you have too many tools, the LLM might call into multiple tools and then consume a lot of tokens. So those are the things we need to be careful about. Also, sometimes we need to make some distinction between read tools, write tools. So for example, for read tools, user can read certain data, but to make changes, we might have to create additional security layers on top of it, so that only the allowed user can invoke certain tools. And then the third one over here I mentioned, which is observability. So if you don't have observability, that means you are basically working on a blind. You are pretty much blind. You don't know how many tokens are being consumed and what's going on inside the application. So observability is extremely important. So that's another layer that I'm going to demonstrate. And finally, that's extremely important, which is guardrail. If you don't validate your input or output, or even the fallback path, when things fail, that's really a problematic. User can create user can provide some prompt, that's probably may end up breaking your system, right? So all sort of things can happen. So this is the so for our applications, this is probably the target architecture. I want to keep that in mind over here. So what we're going to do is everything starts with the user message, and then but we don't send that directly to the LLMs. Rather than we first pass through an input guardrail. So basically that's validate. That's a validation. It's like a Spring Bean validation. This is where if there is an unsafe input, for example, some sort of sensitive things, we're gonna sort of protect the here. Basically, we don't pass that element yet. So the way we send error report to a REST endpoint, if something is wrong, then we send an error message. So we're doing the same thing over here. So next level is essentially RAG, where we bring the business context to the model. LangChain 4J retrieve relevant chunks and passes along to the LLMs. If this step is weak, everything downstream is suffer. So we have to be careful about that. Then we had hit the primary model. Essentially, the idea is we'll always keep a fallback as well. If something happened, for example, primary model cannot handle these, for various reason, we can fall back to the secondary model as well. And then finally, we return, then we send that output to the output guardrail. That's also validate, enforce structure, make sure that safe and useful. And then finally, we return a type response. So not just raw text, so that we can work, our entire system can work on that, typed information. We can also sort of test and validate and do other things. So we'll keep coming back in this, in this entire presentation. So let's move on. So first one is data accuracy, right? So what we're gonna do is over here right now, it doesn't have RAG, so we have like 7 stages over here. So now we're gonna do the stage 2. So what it does is it's enable RAG now behind the scene. So I created it just for making demo safe, right? So now let's see if it works. If it works, that means I'm accurate. I'm doing fine. So let's see what happens. As you can see, now it's giving me accurate information. Since it's after 21 days, you would not be able to return often headphones in Canada that must be done within 28 days. 21 days. It's like slightly still, but anyway, it gives me certain information that actually here that I have written over here, right? So that means RAG is working. Okay, so that's why we have to be really careful, right? We have to measure it, tune it based on our needs, based on our accuracy. We have to test it. So there are different kinds of ways we can do that. So the idea how we make trustworthy, that's the steps over here that I explain in the slides. The idea is we index our business document, retrieve relevant chunks at request time, and then inject the context into the prompt, right? But the important engineering habit is that we evaluate retrieval separately from the generation, and there, and then we look into the query and return chunks, their scores and their sources, without involving the model first. So that's how we test. That's why we need an evaluation module. I'm going to show you that, and that's sort of lets us a clean question. Did search find the right evidence? For example, I write something on the chat box, so I need to get the right information first, right? So there are different way of retrieval, dense for the meanings, lexical for the exact mass, metadata, all those things. I have configured that in the source code. I will probably show you that if I have time, but I'm gonna sort of spend a little bit time on here, which is how we evaluate the retrieval. So over here in this source code, I have a module called eval. So that's where we're going to evaluate our retrieval, how accurate it's based. So what we do over here is we keep a golden data set of realistic stored questions and run retrieval against it offline without the LLM. So this is our golden data set. So over here, based on that, we run this. So over here we have I have written this evaluation logic. Obviously you can see that offline later, but I'm gonna just run it for now. So what it does is, so it just load the RAG module for me and then run evaluation. So over here it says I have run 13 cases and precision at so I wanted a one top K, basically how many item I wanted. That's how I did it. But you can change it, make changes like precision at 5, precision at 3. It's up to you essentially. So here's the slide. What does it mean essentially? Precision K at K means that at the top result relevant, and then we have also another matrix called recall at K. Did you find the expected supporting docs? Also, and then following other things. For example, supported answer rate. Did retrieval give me a consistent, give the assistant enough grounding? Content mass. Does the retrieval text also contain the needed facts? And also we have to look into the latency as well. If something takes a long time, that's a problem as well. And if we see our our cases over here, as you can see, this is our threshold that we put in the code, and it provided like 0.93, which is really accurate, extremely accurate, and recall rate is also high, and supported answer is also high. So basically our test passed. So we're going to keep on running this, and we can also add additional data, so make it our RAG grounded. So that's the idea. We have to keep those in mind, essentially. So now moving on, so that goes the second part, which is retrieval, right? And as you can see, it also return for the demo. I also sort of return which part of the documents is contain that information. So over here it says CA returns empty, so that I can check and really see if it's really saying the accurate, even from the UI. So I prepared that for the demo region. Now we have got reg and everything, but what about I want to know the order status. For example, where is the order? This number essentially. So if I send this, it will probably not be able to tell me. It's just saying I'll check the status of order for you now. So if I say, hey, go and check it. Let's see what it returns. It's just saying I'll check the status of order for you, but it doesn't do anything because it doesn't have tools to do that. So that's why we're going to enable the tools over here, and now we're going to run the same things over here, which is let's see. So now it's really can check these informations. It's currently in transit and left the Birmingham hub. It is expected to be delivered tomorrow. So it knows that, and from the system, essentially check through the database. So how tools work essentially? It's user gets a questions. LLM will decide which tool to call, and then there's a bunch of tools that we created. We provided the system. For example, we have a module for that over here. So let's see. Let's go into these tools. We sort of separated these tools. Stored read tools and then also write tools, just to make sure we have for the write tools we want to create a separated security layers. So these are the tools essentially. Let's open the store read tools. So these are essentially Spring Beans, the way exactly you create traditional Spring Beans. So what happens over here? So let's say I have 10, 20 tools. We're going to add all of them in our configuration. So if I go over here, as you can see, I got this store tools over here, and since it's the bin, it's automatically injected. And then when I'm going to create it, I'm going to create the configure assistant. For example, this is our configure assistants, and since I made this demo to be enable disabled at runtime, so I'm using feature flag. That's why based on the feature flag, if it is enable, then I can sort of just add over here store tools. So that's how it works, and it also the tools also can run concurrently using the new virtual threads. So I'm using virtual threads over here. That means tools can multiple tools can run parallelly. That's interesting. And as pretty much as a Java developer by now, you probably know that virtual threads has a plenty of you can create plenty of virtual threads. That means gives you a high level of concurrency. Anyway, moving on. This is not a talk about virtual threads, but I thought I got the opportunity, so I wanted to just share that. And then LangChain4j basically validates and call your tools methods. Your Spring Bean executed, the order service get a status, and result returned to the LLMs, and LLMs formulate natural language response. So over here, the difference between our regular irregular in the Spring Beans is that it's more like an get mapping. Like when you were creating a resource, you use get mapping. Tools is like that, and P is like your request param. Just keep it put in the perspective. So it's not new. It just it has a different name, different way of expressing it, but it's pretty much the same. It's just calling a different thing from LLM perspective essentially. So the easiest way to understand is this, that a tool is just your API exposed to the LLM. So they're regular Spring Beans. The only difference is that we annotate with the add tool annotation, and now the model can choose to call them when model feel like it. Essentially, you can it, it's not so this is how you can put it. So look at the first one right over here, get order ID status. It takes a simple parameters order ID and calls the service. Same thing for inventory. And so the code is very normal. What matters is that the contrast you are defining, contract you are defining, the name, the description, and the parameter. That's what model reads. So this is how it decides which tool to call and how to call it. So in a way, your tool definition is like an API docs, but for the model, not for the human. So you have to be very careful about articulating how we're gonna write tool descriptions, the parameters, so that it's native. It's easier for the model to understand. So you want to provide as many as information to the LLM to decide, but then you don't want to make it way longer so that it consume a lot of tokens. So you have to sort of kind of find the trade-off over here. On the Spring side, since I'm using a Spring boot over here for this application, so from the Spring side, nothing really changes, I would say. These are still beans. You can inject service, reuse your existing business logic, and keep things clean and modular. And the LLM is not executing your business logic. It's only choosing the API to call. So you have to keep that in mind. And so that safety, correctness, validation, all of this is still your responsibility. So yeah, like if you have some dangerous tools, for example, that change some certain things in your database. Like I said earlier, you have to add security layers on top of it. And that's the key idea essentially over here. All right. So that's a tool demo. So you have to be very careful about how you define tools, and also, for example, over here, the pricing tools over here, right? This one actually probably what is the price of in Canada. So this is going to be a pretty expensive one. And also there is another tools over here, kitchen sinks. Tell me everything about all the products in the region, every region. So this is going to be okay. So something is not working. I'll have to look into it. But the idea is this tool may consume a lot of tokens. So you have to be very careful about those aspects. How we're gonna know which call and which interaction is consuming a lot of tokens, doing a lot of communications to LLMs. How we're gonna find it, right? You have to know that. If that's where observability is extremely important. So if you are like, if you don't have observability, you are just blind, you are just guessing. So we as a Java developer, we don't like to guess. We want to see what's happening behind. For example, over here, as you can see, I also enabled, by default, which is called observability. With we have like, what do we say? Open telemetry, so that those information are fed into a external service, for example, Grafana, all of those things, so that we can see nice dashboard over here, like this. Distributed tracing with Grafana. You can see over here, all the trace ID and related start time, which service is calling, which response is getting, and which particular tools is taking more times, and which tools consuming how many tokens, something like that. So for example, over here you can see I have one trace ID like this one, and then it's calling multiple things over here, as you can see. And over here I have specific sort of window of time each particular one taking, so that if something goes wrong, if something is taking way more supposed to be, then we can diagnose that. For example, over here the tool get price is taking 3.6 millisecond. Is it it looks like, compared to other, it's pretty fast, like. And if it takes like way longer than expected threshold, then we have to look into it. And also we have sort of pinpoint the log along with that particular chunk, span ID, right? So that's where observability is extremely important. So over here, I have created a dashboard over here, and so far I have sent total 3 requests, or probably I have to refresh it. So let me say refresh. Okay, I have sent total 13 requests, and how many total token I have consumed, input token, output token, all of those things, lowest. Yeah, so all of this configuration are here over here in the Grafana. These are Docker, so you can just try and if you just run this compose.yml, you will get everything. But the key things from here is these are the important things for your production readiness. You definitely have to know what's going on, where I'm consuming most tokens, and how to optimize those things. So yeah, so this is extremely important. Anyway, so was the third thing that we need to look into, right? And then finally, I think I planned like 4 aspects. So because the presentation is 30 minutes, but there are plenty more we can talk of. But the final one that I'm gonna demonstrate, which is called reliability. So the idea is we have to introduce guardrail. The goal is not to pretend we can eliminate every problem. The goal is to make failure mode explicit, bounded and understandable, essentially. So every guardrail is a unit testable component. They are deterministic Java code. This is the flow, essentially. We start with the input guardrail, and one block prompt injections. The other gets right for the if there is a right actions that needs, we can protect using the right intent guardrail. Basically, we can create as many as a guardrail we want to. And over here, and how we're gonna do that, it's pretty simple. So let me show you how do we write guardrail in applications. So LangChain for the provide us so for example, this project, this is an idea. You can have more robust guardrails. So it provides an API called input guardrail. So you can implement that. And then it has a method called validate. So you get the user message, and then you validate against your logic, essentially. So I have these block patterns, like if something like this comes to my, comes through the chat from the users, I'm going to block them. So over here, I'm just, for naive pattern, I'm just using, matching with this pattern, block pattern. And then if it is blocked, I'm just returning a suspicious instruction manipulation attempt detected. So let me see if I can demonstrate that. So what I have to do is I have to go into reliability. And so
Baza, before you show the reliability demo, just a note on the time. If you could wrap up, we would appreciate that for the next speaker.
So this is the last thing, essentially. I don't have much more so things. For example, if I want to do project injection, so it, as you can see, it's basically blocked. I cannot help you with that request. So this is essentially the input prompt injection guardrail, right? So you can have multiple guardrails, input, output, and I have a few over here just for the demo. But this is the whole idea, essentially, and this is how it works. This is the structure, and we get also structure output, like similar, like how DTO works in the LLMs. LangChain Portia also offer that. Basically, they provide a deterministic Java code. That's why, and if you sort of make the contrast between Java, the LangChain for LLMs pattern with your known Java pattern, it's pretty much similar. You get a structure output over here. In Java, it's a DTO records. You have input guardrail. There you have like pin validations, and output guardrail, it's like response validation. Similarly, for observability, you have micrometer, open telemetry, same things. So I'm not, since we are out of time, so you get the idea. Essentially, you don't have to know a lot of things, but you just know how the contrast works, essentially. This is essentially my final slide. The LLM is just another external dependency, and as Java developer, we are sort of proud of that. We are really good at building reliable system on top of unreliable dependencies, and LLM is another unreliable dependency. And beyond this talk, these are the things that we need to think. I didn't have time. If it was longer than 30 minutes, I'd probably touch some of this component, but take these notes and try it out by yourself. So that's all I have to offer. So you can take the slides from this QR code. Also, you can take the source code, and here's some contact information that if you want to reach out to me. And also I have my books over here if you are interested to getting a copy of it. Thank you all. That's all I had.
All right, Boulder, thank you so much for the presentation. Very deep dive, very code heavy. We love it. And I'm sure the developers watching the live stream and then watching the recording later will appreciate as well the level of details that you put into demonstrating how to build that Java application, how to build an intelligent application using LLMs with LangChain for J. For our next guest, I would like to invite on stage Savi Grover.
Hi, Bruno.
Hello, Savi. How are you?
I'm doing good. How about you?
Good, good. So did you enjoy Basler's presentation?
Yes, it's a package full of agentic AI and Java and combination of how AI is optimizing our workflows. I'll be diving deep into one of the other topics, which is related to Java testing. Yeah, please carry on with the introduction.
All right, awesome. Basler, thank you so much for your time. I hope to see you at the next JDConf as well. Have a wonderful day.
Looking forward to. Thank you. Thank you, everyone.
All right, Savi. So testing, I mean, we can easily build applications now. We can easily build tests now. But one thing that kind of tricks me sometimes is I ask an agent to build a new feature, and instead of fixing bugs, it changes the tests. How do you deal with that? And is that something that I hope that we can learn through your presentation, how to properly manage AI when using AI to build features and then build those tests and manage the tests, so we are not letting the AI trick us by manipulating the tests just so that tests pass. So I'll leave you on the stage, but please start with a few minutes on an introduction about yourself, so that the audience can learn about you and what you do, and then just take it over, and we'll be here for the next 25 minutes. Thank you so much.
Thank you. So thank you for organizing this wonderful conference. For the committee members and all the participants, I've been watching it since the beginning, and it's a full package of knowledge, new Java advancements. About myself, my name is Savi Grover. I am currently working as a software reliability engineer, started off as a test quality engineer, worked with a lot of clients, including Ford Motor Company, NBC News, and recently working with CNBC. I'm sure all of you must be aware about the channel. So how AI is changing our build, test, and deployment pipelines. I'll be sharing this slide as well as going through with each and every pointer as how we are utilizing Java advancement, especially Java 26, which is a new Java version, and how it's changing with Java 17 and the older versions of Java. Starting with my slide, my agenda here will be why we are using AI in Java SDLC, how it is helping us in building intelligent processes, script and test automation, also in deployment intelligence and agentic orchestration. So moving on with the current landscape, if we see the Java SDLC lifecycle right now, it starts with writing the source code, compiling it to bytecode class, and then loading that bytecode in the package using Jenkins or using any Docker file tools, verifying it, preparing it for shipping purposes, and then executing it. So why is AI needed in this life cycle is because we have a lot of increased system complexity. We need faster release cycles. There is a lot of redundant code which needs to get optimized. We need some reliability at scale because doing this in a linear fashion takes a lot of time, and AI enables the predictive and adaptive side of these systems. So the shift is basically moving from deterministic scripts to probabilistic agents. We no longer have the linear code processes where a program after running will give a defined set of outputs, but with AI in the system and with agents in the system, we get a probable approach where we get a range of outputs into the system, especially by training these agents and training and getting the tooling system by MCP. So key stats for the recent updates is 61% of Java code in the enterprise environment is now AI generated or AI augmented, and the cycle times have dropped drastically from 75% due to the boilerplate hell and boilerplate reduction. That means repetitive code, repetitive cycles have been eliminated, and AI isn't just a coding assistant in our ID, but it's more of like a control panel where we are updating the application and side by side chatting with an agent that how can we normalize a bug fix, how can we debug a particular workflow within our application, how can we do component testing, and how can we introduce unit testing into the picture. So building intelligent builds, here we are no longer using MVN clean install, but because the traditional builds are slow, they are resource heavy, and AI build time is significantly reduced by finding out new and old changed files. So we are training a tool like GitHub Copilot where we are directing it to find out the distinguished files which are not the old files and finding out the new changes into those files. Predictive build systems, that means triggering selective builds, identifying impacted modules only, and this can enhance our testing impact analysis because we are targeting directly the git gifs, directly the commit patterns on the branch code, and specifically run tests affected by that change, which is reducing our CI time by almost 80% in some organizations. And even it helps in resource forecasting, that if we integrate it by a reliability tool or a Datadog pipeline, we can predict how AI computation is taking systems resources, maybe RAM, maybe memory, maybe CPU, and we can forecast these changes for a build based on all the historical data we have, and especially optimizing the ephemeral runner costs. Then building script optimization. So not only we want to test our interfaces, our testing also involves black box testing. That means we need to test what the developers are writing code on, what are the code cycles, are we having circular code paths, we need to prune old unused code and come out of conflict resolution. So manual maintenance of pom.xml, as we saw in some of the fewer other presentations, that pom.xml had a lot of dependencies. We have build.gradle files where we keep accumulating a lot of dependencies as the project is enhanced. So all of these are being replaced or optimized by agents that understand the entire project context. Dependency pruning and conflict resolution. So here we deploy certain models which analyze our actual bytecode usage and identify what are shadow and what are unused dependencies that bloat our jar files. They can automatically resolve complex version conflicts that previously required manual exclusion rules. Even we have dependencies of older versions present, which we no longer use the jar files for. So all those things are cut off and they are pruned from the system. Conversion and modernization. So tools like Cursor and GitHub Copilot Workspace, they can refactor a legacy code, which is thousands of lines of code, into a concise idiomatic Gradle Kotlin script which is in seconds, preserving all the custom logic, but this needs a lot of training. So we have to include these chatbots, include the LLMs from the starting of the system, from the starting of development pipelines. Lastly, performance tuning. AI identifies bottlenecks in the build lifecycle, example, redundant unit tests or slow annotation processors, and suggests some parallelization techniques in incremental build configurations, which we can deploy within our test scripts to enhance the test running lifecycle. And then going out for enhancing code quality and maintenance within the code lifecycle. So here we can deploy intelligent debugging methods. AI can identify nuanced bugs like concurrency issues, race conditions, certainly different DB issues, and provide a common solutions on profiling tips for code warnings. We can deploy a tool like SonarQube, which warns us with certain like conformances issues within the code. Automated refactoring. Here, AI acts as a vigilant code reviewer, spotting redundant code, even complex nested statements, suggesting more cleaner, modern, and alternatives like switch expressions and case expressions, or for loop is replaced by for each in certain scenarios. And moving on to version upgrades. So tools like GitHub Copilot can also upgrade our assistant automatically. If we are using large scale tasks, we can migrate our code from Java 8 to Java 17 by refactoring code and updating dependencies within the IDE. Now AI in testing, that means automating repetitive development. So the autonomous test generation and boilerplate generation, we can use assistants like GitHub Copilot, and even JetBrains have their AI assistant, which automatically can generate repetitive code, such as they can set the getters and setters file. We can have the null check, we can have exceptional handling, and certain standard loop structures reviewed and checked. AI tools streamline the routine aspects of Java development and allowing engineers to focus more on high value architecture. Unit tests creation. So agents here analyze method signature to propose initial state test cases, covering edge cases, null checks, side edge cases, and which introduce manual effort in testing. Proper test documentation. So tools can automatically even generate and update a Java doc or a MD file and other documentation for these methods and classes, ensuring they stay in sync with the updated code changes. And then we have a method for test prioritization and flaky test detection. So we face a lot of struggles when we have repetitive tests, and those are flaky tests, finding out stale elements. If we have certainly wrote a script for automating all of these procedures, some of the elements on the screen, they go stale, they go bad, they are outdated, and there is a way of how we can employ AI to find those and reduce those flaky tests. So context aware unit test, we can use tools like JetBrains within Spring Boot and Jakarta, and to mock these dependencies accurately. Boundary analysis. So here AI automatically identifies edge cases, overflows, empty collection before running the tests. And then we have legacy modernization, where we auto generate tests from the old black box monoliths before refactoring. So if we have a new test build, the older test will first run, and then it will be refactored based on the new build, and we find out the differences between those to target flaky tests. So flaky tests crisis here is deal by self-healing tests, which are basically UI changes which break our Selenium locators daily. AI can detect these UI and API break rates. So how the self-healing actually works is, first is it is detecting a test fail because of an ID change or a XPath changed in the HTML DOM, automatically updates these locators, and assertions. And then it does a heuristic rescanning. That means AI analyzes the DOM structure for these similar attributes. It will understand the CSS, the divs, the classes, labels, what is the proximity, what is the parent-child relationship between the elements in the HTML DOM. It does automatic repair. The script heals itself during execution and submits a PR to update the test code. And we can use tools like Mabel and Blink.io and test him, especially for Playwright, if we are using the automatic repair feature. Failure detection can be logged. It can be recorded, and it can be seen in the logs if we are debugging the tests. There are root cause predictions which automatically are targeted within the script. We also have a historical failure analysis where all the traces and all the past failures are seen and the changes are made accordingly. And we have faster debugging, especially in Playwright, where we can debug an individual script. We can also debug in the inspector layer of Playwright and find out what were the flaky tests or what were the flakes were discovered. Then moving on to the AI guided deployment flow. Here we are no longer doing an manual approval or manual reviewer of the CI/CD process. We are basically using a risk scoring factor where AI assigns a risk index to every PR based on code complexity, based on past bug density within the code branch, and also developer experience. So here we can have autonomous gating where low or high risk changes are tagged and they are marked. These can not bypass the manual gates for instant deployment, and these can be programmatically put into the Git or put into our branch for bypass rules or by reviewer rules. We can also employ an agent within this layer that if the agent discovers any inconsistency or discrepancy, it can completely block the PR merge process. And patterns here, the canary release patterns could be directly managed by AI agents where we can have two reflective branches, have the new code change, and we can just release one branch to have a limited user first testing it and then merging it for the broader audience. So coming on to agentic orchestration. So in 2026, the rule for AI in Java build process have evolved from simple code completion to agentic orchestration. It no longer suggests any snippets, but it actively manages the plumbing of our application and optimizing our build scripts, managing dependencies, and self-healing AI CI/CD pipelines. So an example of this agentic orchestration here is, for example, the pipeline is no longer a linear sequence, but it's a conversation. Developer is first building a new REST endpoint for orders, and agent one, who is a building in charge, scaffolds this code, creates a Docker file for packaging this code. Agent 2 is basically generating 95% of the coverage tests, 5% of security scans, other edge cases in order to have the unit tests run on this code. Agent 3 is doing certainly a deployment task where we perform a blue-green rollout, which is again a canary rollout, and it also monitors our 500 errors or is clubbed with a Datadog agent to monitor all the crashes or all the faults which can happen during the deployment process. And finally, all of these are supervised by a human reviewer who has strategic directions, when to block the process, what is a hard line for a no, and what is a hard line to pass this whole process. Thank you for the presentation and thank you for the session today. You can connect me with me on LinkedIn on my ResearchGate. My recent paper currently have come out on vulnerabilities and risk analysis of multi-agentic AI RAG, and I've also written a paper on flaky test mitigation in the agile landscape. So you can have a look and you can directly reach out to me on my LinkedIn.
All right. Well, thank you so much, Savi. This was a very enlightening. I don't think I've ever saw a presentation like this, getting us through the details of using AI agents throughout the testing phase of software. And I really appreciate you sharing that. I'm curious about the paper, and I'll take a look at it as well. And for everybody watching, please do the same, and then go to Savi on LinkedIn and share feedback, because I think you will appreciate that as well. The next presentation, interestingly enough, let's welcome Anthony on stage. And Anthony is, hey, Anthony, how are you?
Hey, how are you, Bruno? Doing good?
I'm good. I'm enjoying the Montreal weather finally, and I know you're also based here, so
Yeah. This is a great day. It's super sunny today.
finally having some sun.
Yeah.
And Savi's presentation just before yours was about testing with agents and self-healing tasks and so on, about security as well. And I think your presentation touches security and vulnerability scanning and the art of CV lifecycle and managing that. And I wonder, can we trust AI agents to find security vulnerabilities? And then can we trust them to fix security vulnerabilities?
Yeah, this is definitely a good question. And this is a hot topic, actually. Some actors involved in the AI landscape already started shipping some products in preview. I know for a fact that Anthropic Cloud, they have a security offering that is still in beta, not official yet. So I know that companies want to kind of replace the static analysis with AI-enabled analysis of security patterns in your app. So yeah, this is definitely coming. It's not yet usable. It's not out there yet, but yeah, this is definitely coming soon.
I think there are two elements here, right? One is matching existing vulnerabilities with the application code, with the entire system. But the second part is, can we use AI to find novel security vulnerabilities?
Yeah, that's a good point. Because you're right. Static analysis is just based on known patterns, right? So what AI could enable actually is to find new ways. And I think this is definitely what's going on. And I think that those models have been trained on what researchers and experts have been doing during the last year. So yeah, I'm pretty sure like AI has taken over the world in many parts of the software industry. This one too, I think, will benefit from all those years of training.
All right. Well, so your presentation is the last presentation of the Americas time zone, and I would like to appreciate every speaker so far. And for folks still watching the live stream, stay tuned after Anthony's presentation. We're gonna share a few QR codes for folks to participate and engage further with Microsoft JDConf. So Anthony, please take it away. And for everybody watching, take a look at Anthony's presentation. We'll talk soon.
Super. Thank you very much, Bruno. All right. So you can see my screen. I can't see you anymore, but I assume you can. Yes, Bruno?
Yeah, we can see.
Excellent. Thank you very much. Let's get started. From vulnerability to victory, mastering the CV lifecycle for Java developers. I have shared a few slides, all the slides and some references. So if you scan this QR code, you will get it. But I also posted it in the comment on the YouTube link. Okay, let's get started. Software developers, they definitely have security responsibilities. One of them is, of course, make sure that we do not add new vulnerabilities into our own code base, right? So there is the OWASP organization that has been compiling a list of the top 10 vulnerabilities that you could actually insert in your code inadvertently, and that could unfortunately compromise your system. I guess that most of you watching this stream today, you're already familiar with the OWASP top 10. I know that there are some trainings that are given across organizations. So you're probably already aware that your code needs to be secure from the commit. But this is not just your apps that we're talking about. This is not just your code that we're talking about. We're also talking about all the dependencies you ship. For example, if you're working on a new app, let's say a customer dashboard app, and you know for a fact that there are no known vulnerabilities, Are you sure that it's the same for all the dependencies that you've been using? If, for example, you created your app a year ago, how can you make sure that all the dependencies, all the libraries and frameworks that you embed in your app are also secured? Do you make sure that you update frequently? And also, do you make sure to migrate before the frameworks and libraries are getting end of life and they no longer maintain the code? You have also this responsibility because otherwise, unfortunately, a CV in your stack is kind of the same impact as a CV in your own code. Malicious actors could actually benefit from it. And obviously, you don't want to be the developer that will have his or her app inside a dashboard listing all the vulnerable components. I mean, you don't want to have high severity or critical severity components in your application. So you need to work on that and make sure that, yeah, your app will not show up in such a dashboard that we're going to describe just after. My name is Anthony Dahan. I am a software engineer, and I recently joined a company named HeroDevs. What we do at HeroDevs is simply maintaining the open source libraries that are no longer maintained by their original maintainers because the maintainers have moved on to later versions, or maybe they just abandoned the project. So we're here to support that. When I'm not working on HeroDevs and vulnerabilities, I am also a maintainer of the Paketo build packs, the Java build packs in particular. You may already be using the Java build packs if you're using, for example, Spring Boot to build your container images. This is the default way to create container images. Also, I am involved with the local community in Montreal. Like you said, Bruno, we both live in Montreal, and I help organize the Montreal Java user group, monthly meetings, as well as the DevOps for Kids workshops for children aged from 5 to 14 quarterly. Now, back to the presentation. Yes, Bruno, we already talked a little bit about static application security testing. We're going to dive in a little bit more just after. But also, we will deep dive into the dependencies, the software dependencies that you ship with your application. First, how can you create a list, an SBOM, and how then, for each component found in this list, can you assert whether or not they expose a critical vulnerability issue? The goal of this presentation is to help you understand how you can reach the goal of 0 CV in your code, 0 vulnerabilities. Static application security testing, it's pretty easy to use today. Honestly, it's pretty mainstream. There are so many tools that you can already leverage to know whether or not you have inserted new vulnerable code in your app. Those tools, you can run them directly from your IDE, such as IntelliJ, VS Code, Eclipse, and so on. Or you can also start them from CI. I personally prefer to use them in both the IDE before commit and also in the CI before the PR is approved. That way, you know that you're not going to ship vulnerable code. There are many commercial and open source tools. I suggest we have a look at an open source tool that is the Spot Bug plugin. So to use the Spot Bug plugin, you need to add it to your build. So it should be over there. Here it's in my Maven build. I can see that I have GitHub Spot Bugs, and this plugin, surprisingly enough, has another plugin that is named Find Security Bugs. And this is the one that can detect vulnerable patterns, basically. So Find Security Bugs is actually developed by another developer from Montreal, Philippe Artaud. So yeah, let's have a look. I already generated the scan. So now I'm going to start the UI to see what vulnerabilities were found in this old code base. And okay, well, we have 12 security issues. To be honest, I kind of intentionally added them for the demo purposes. Let's have a look at this one, SQL injection, JDBC. So if I click on this one, the tool is going to pinpoint exactly on which line there is a potential vulnerability. And as you can see here in this example, this REST controller accepts a string, and this string is never sanitized before being inserted into a SQL query. Very bad. And obviously, this is SQL injection could actually be happening. If you have another security bugs that you found out that is more complicated or that you're not familiar with, for example, the cool thing is that the tool is also going to give you some information on how you can fix it manually yourself. And also, it's going to give you some references, some reference link. And I really like the CWE ones. They are being maintained by an organization named Mitre. And this organization is actually referencing close to 1,000 vulnerability issues. So of course, I don't expect all developers to know all the different common weakness enumeration, but at least the cool thing is that you can click on the link and you can learn about it. So what I'm trying to say is that all developers have the means today to ship secure code. There is a lot of documentation around it. But as I said during the introduction, it's not just your code that you ship to production. You also ship a bunch of dependencies. In the Java world, it's very common to rely on, for example, a web framework, for example. And if you ship to using container images, it's also possible that the base image of your application could ship also libraries that could be, unfortunately, vulnerable as well. This is why you need to know exactly what goes to production. Of course, if you are a Java developer, you're familiar with Maven and Gradle, but all the dependencies that you put directly in your pom.xml or your build.gradle, they may have transitive dependencies. For example, library A that you specifically put in your build could depend on library B, and library B could depend on library C. And all those three libraries will actually end up in your package that you're going to ship to production. So you need to list them all. You have ways using Maven or Gradle to create such a list. But the interesting thing is that the industry as a whole has a format that works with every programming languages, not just Java or JavaScript or Python, but just with all of them. We call that a software bill of materials, which is agnostic to the programming language. Unfortunately, there are several formats of SBOMs, but today I'm going to focus on Cyclone DX. Why? Because this is the most popular across software developers. And it is a standard that is highly recognized across the tooling. What does an SBOM look like? I mean, a Cyclone DX SBOM look like? Here, as you can see, I have an example of a component part of an SBOM, and this SBOM is formatted in JSON. It could also be formatted in XML. As you can see, for each component, here, EHCache, we have a bunch of information, such as the publisher, basically the maintainer of the library, the group, the name, and the version of the library, a description summary, a license, very important. This is not a free form text. This is actually, this string Apache 2.0 is part of a list of licenses. But the most important information for each component in your SBOM is the PURL, package URL. And this package URL is going to identify the package in one single string. Here, package Maven, it means that it belongs to the Java world, not specific Maven, by the way, but it could be package Go, package Python, package NPM, and so on and so forth. Then, after the type of package, you have the group ID / artifact ID at version ? The type of artifact. Is it a jar? Is it a WAR? And so on and so forth. There's also another format that is named CPE that exists, which is more used across hardware components like routers and NAS and so on. So for software, usually the Perl is the best way to represent a component, a software component. Obviously, you're not going to create those SBOMs manually. You will want a tool to do that for you. I would like to mention Sift. Sift is an open source software, and it can not only scan libraries just looking at a given folder and then digging across this folder and finding all types of libraries. It can also work against container images as well. So it's going to open up your container image and also scan and try to find all the libraries and components that you used in your image. Sift is a very nice tool. It can generate the SBOM in different formats, CycloneDX, Sift, and so on. There's also the Maven CycloneDX plugin. Also, many commercial vendors, they are able to generate SBOM. And if you subscribe to a commercial vendor, just make sure that those vendors, they allow you to export the SBOM using a format like CycloneDX so that you won't suffer from a vendor lock-in. Once again, CycloneDX is a great format. Interestingly enough, your favorite framework may already create an SBOM for you. Let's have a look at Spring Boot. Since version 3.3, they actually allow you to create and expose an SBOM directly from your app. Here I'm changing my branch, and normally I think I have set up the actuator. So the actuator is right there. Okay, it's added to my build, and let's see if it's properly configured. Yes, here you can see that I have configured the actuator to give me information about the health, the bins, the loggers of my application, as well as SBOM. All right, so let's see what it looks like. If I go there, so here, for example, I have the actuator endpoint. If I scroll down, I will be able to find the SBOM. You may think that there's not much information. It's because this feature from Spring Boot is extensible. By default, it will give you an SBOM of just the Spring Boot class path, basically, but you can also configure it to leverage an SBOM from your base image, for example. Very convenient if you're using Paketo build packs and the Paketo build packs created an SBOM for your base image, or if your base image already includes an SBOM, you can actually reference it and have it under this endpoint. So let's have a look at the default one created by Spring Boot, CycloneDX version 1.6. Okay, fair enough. And here, as you can see, 89 components were found. Let's take this one here, for example. This is Logback Classic. And as expected, I'm going to find a Perl for each of them. So thanks to this list, now I know exactly all the components that I am about to ship to production. The story doesn't end here, though. You can now analyze this list. Here in this project, I have a GitHub action, and this GitHub action is going to not only build my image using build packs, but it's also going to generate a full SBOM of both the base image as well as the application. Here, I'm using Sift. As you can see, the command line is pretty obvious. Once my SBOM is generated, I am going to upload it to another tool, which is named a software component analysis tool. And here, I'm going to use dependency track. Why dependency track? Because it's open source, it's from the OWASP Foundation, and best of all, it's written in Java. So once I have generated, once I have sent this list of vulnerabilities, this SBOM, to my SCA, then I will be able to have a look at all the different all the different components and their vulnerabilities that were found in those components. Here, for example, I can see that there is definitely a bunch of vulnerabilities. This is pretty bad, 200. But once again, this is here, I am using an end-of-life version of Spring, and I'm using a big Ubuntu image with a lot of dependencies, and unfortunately, it's not up to date as well. You can definitely do better than this. For example, if you still use a maintained Spring Boot, if you use a maintained Spring Boot version, then of course this number will drastically go down even to 0, possibly. Okay, so how does that work? As you can see, I generated my SBOM and then I send it to a software component analysis tool. What is not visible from the UI is that this tool is going to periodically check against vulnerability databases to actually know about all the new CVEs, all the new vulnerabilities that are out there. Usually, you would want your SCA dashboard to connect to NVD, which is managed by the US Department of Commerce, as well as GitHub Security Advisory, managed by Microsoft, and also OSV, which is managed by OpenSSF, as well as Google. Of course, there are some local advisories from different countries, such as Canada, United Kingdom, and also the European Union, where they have also their own databases. The interesting part across all those databases is that at least if they're different, they still sync on the identifier of the CV. Whenever you see a CV that starts with CV dash, usually all those databases, they know about it. And even if they have their own identifier, they recognize this one and they link to the CVE one. So no worries on that. Now, how do those databases get fed actually with new vulnerabilities? Well, anybody can actually find a new vulnerability in some software and then ask to, and then try to disclose it. To do that responsibly, though, you will need to contact the maintainer of the project. Of course, there are several ways to contact them. Maybe they have a GitHub advisory link where you can create a new issue. Maybe you just email them. There are many ways to contact them. The important thing is that when you contact them, it needs to be a secret, because probably you found a vulnerability that could be used by a malicious actor. Then the maintainer of a project normally is going, if they find that this is a good report, they will create a new CVE number. For that, they need to be a CNA, a CV numbering authority. And then they're going to submit a new CV once again to cve.org. They will make this vulnerability public only when they have fixed it and they have a new update available to their users, so that whenever there is a new CV created, there are always mitigation steps, the best one being to migrate to the new version. Unfortunately, if they don't answer, then you have no choice to just disclose yourself. A very interesting thing that's going to come out with the CV is the rating of the CV. Maybe, for example, I've shown to you during the introduction that there can be high or critical CVEs. It's going to depend on how easy it is to exploit it. For example, if the score is above 9, it's critical. If it's above 7, it's going to be high, so on and so forth. It's going to depend on all those criteria. And the cool thing is that all those criteria are going to generate, to give you a vector string. And this vector string is kind of a summary of how this vulnerability can be exploited. You need to make sure, for example, to be secure, to use to make sure that your base image is up to date and that it does not contain too many libraries that can actually get new CVEs with time. The one way I suggest you fight against this, against base image vulnerabilities, is to basically have the smallest base image possible. Good news is what used to be only commercial product, I mean, There are still commercial products, but there are many free options now that are possible to you. For example, if you rely on Ubuntu, Debian, or any other known OS, Alpine, and so on, there are versions that come CVE free guaranteed, such as Docker Hardened Image, that was back in December, Chainguard Wolfie for several years already, and so on and so forth. Now, back to Java. For the Java, to make sure that you're not shipping Java vulnerabilities, well, you need to have a look at the version, at the next version that you can use for a deprecated or an old version of your library. For example, when you set all your dependencies, usually the maintainer is going to use semantic versioning. What does that mean? It means that the version of each component shipped by this maintainer will have a version with 3 digits. First is major, second minor, third patch. If they do this, they should also respect the meaning of each of those digits. A patch version, a patch upgrade means that it's pretty safe to upgrade. When you go from 1.2.3 to 1.2.4, you know that nothing is going to change. Maybe a bug has been fixed. That's about it. When you go from 1.2.3 to 1.3.0, for example, it's possible that there are some new functionality, but one thing is for sure, the existing functionality is not gone. The signatures are not changed. So you're safe also to upgrade. The worst case is when the library has upgraded the major digit. That means that everything is possible. They could have broken everything if they wanted to. And when you have such migration to do, you need, unfortunately, some energy and some time to actually do that. You cannot really automate this. It's pretty hard. Let's have a look at an example with my Spring Pet Clinic application fork. Here, for example, I have Renovate that is running. Renovate has created for me some PRs. And as you can see here, it has found that the version of Maven I'm using is not the latest one. This is pretty easy, this migration. Why? Because this is a patch upgrade. And also Renovate has also a confidence level, which is pretty interesting. And like they say, they're going to tell you that they can have a low confidence if there is a breaking change, usually when, once again, it's a major. This one is a patch upgrade, so I'm going to do it live. I'm going to merge it. That's completely safe. I am super confident. I even do this during a demo, during a presentation, to tell you the level of confidence. But this one here, this one is unfortunately not the same. Here, Renovate tried to migrate from Spring Boot 3.5 to Spring Boot 4. It's a major upgrade, and unfortunately, many things became incompatible. So here, I will need to either use an open rewrite recipe or maybe use AI to help me out migrate. But unfortunately, there is no free lunch. There is definitely some energy involved doing this migration. The cool thing is that a project such as Spring Boot, they usually give you approximately 6 months to migrate. For example, 4.0 was out in November, and 3.5 is going to be end of life in June. That's approximately 6 months for you to migrate. Use those 6 months wisely. You still have 2 months to do your migration. Okay, so to conclude the presentation, what can you do to be sure you have 0 CVEs? Start integrating SAST, so static application analysis. You can use find bugs if you want to, no worries. And if you have GitHub or GitLab, if you're using it, they probably also have some features to do that for you as well. Start generating SBOMs, even if you don't have a tool to check for them. This is not a joke. The US government and soon the European Union governments will mandate all their providers, all their software providers to give them an SBOM whenever they buy software from them. This is coming, this is real. This is, unfortunately for us developers, that's another thing to do, but it's going to be mandatory soon enough in many regions. Use distro-based images as much as you can. There are no issues with them. Just test your application once with them, and then you're going probably to shrink the number of CVs dramatically, super easily. And also make sure that you migrate your framework as soon as possible before it gets end of life. Thank you very much for this opportunity to talk at JDConf. I thank you all the team at Microsoft for allowing me to be there today. And if you have any questions, reach out to me. I'm pretty easy to find on the internet. And yeah, I hope you like this presentation. Thank you very much.
Anthony, thank you so much. This was a great presentation. I loved all the resources that you shared. I think it's not just, before your presentation, I mentioned the AI would just solve everything, but there's a lot of non-technical things that developers, as you just said at the end, developers will have to deal with. And even though AI can help maybe fill forms and prepare documents, that's still non-technical work that developers have to be aware it has to be done. And I think that's where the landscape of software development is shifting. The technical part is becoming easier and easier these days, but the non-technical part that used to be done by project managers and product managers and directors of IT may actually shift down to the engineering team to actually deal with those non-technical elements now that they have the time to work on those things, make sure that everything is correct and ready to be assessed and audited and validated.
Exactly. Yeah, but it's definitely another burden for developers. So this is why usually security is not like a very popular topic, because that's one more thing to think about, you know. But yeah, as I said during the conclusion, more and more entities are asking for this for transparency with regards to whatever they're going with, whatever libraries they're using. This becomes like something mandatory more and more. So yes, and like you said, probably that developers will need to do that, because you cannot ask a security team to assess the severity of a vulnerability. It has to be the developer, because the developer knows why this library is here in the first place and how they use it. So they can basically assess whether or not it's a danger.
Exactly. Well, thank you so much for sharing. Your presentation will be available as a recording later. There's a lot of great resources there for folks watching live. Make sure to check the Microsoft Reactor channel on YouTube, where all the presentations will be available. Anthony, thank you so much.
Thanks, Bruno. Bye.
All right, so we are at the end of the Americas time zone. We still have the European time zone, the Asian time zone, lots of great content. We have Sandra from the Microsoft Developer Relations team. We have Brian Benz helping coordinate the other time zone, the European time zone. We have a lot of content still. But to continue this conversation, let's just recap a few things that you may hear again, you heard before, and you may hear again. So a couple things that we did learn today were, of course, Microsoft AI Foundry, GitHub Copilot, so many things that are available for developers to interact and to play with are at their hands. It's easy, it's accessible, the capabilities are there. We saw great demos. There's no reason not to experiment and try. But before we move on, let me show you a few pieces of information here. Let's bring this slide here. So this is what AI Foundry has to offer. Foundry models. From one single platform, you got access to all of the AI Foundry models from Microsoft and from its partners. We have access to DeepSeek. We have access to Grok, Mistral, Llama from Meta, NVIDIA models now available, Claude from Anthropic, of course, and OpenAI GPT models, Hugging Face models. The catalog of AI Foundry models is huge, and you can play with it. You can use the AI Foundry Studio and try and test prompts, validate and evaluate those AI models for all the different prompts and capabilities that you may have with your applications. The next thing that we have is capabilities for developers. So when we look at, let's get to the next slide. When you look at the GitHub Copilot landscape, there are a few things that we have to offer here. Capabilities within IDs. We saw GitHub Copilot being used within IntelliJ, Eclipse, Visual Studio Code, Visual Studio Family. We can use GitHub Copilot from github.com with the cloud coding agent. We can now use GitHub Copilot from a CLI, and even more interesting enough is now the latest addition to the GitHub Copilot family, which is the GitHub Copilot SDK. We now have SDKs for .NET, Python, Node.js and TypeScript, and Go. And recently we published the official GitHub Copilot SDK for Java. And here's the URL for you to try. What can you do with the Copilot SDK? Well, you can interact with Copilot CLI and its agent harness from the CLI. But what if you want to have more structure and more workflows that are common within your application, within your tools? That's where the SDK comes into place. You can programmatically interact with the agent harness of Copilot CLI from within your application using these SDKs. The capabilities are infinite, and you can try it right now with GitHub Copilot SDK for Java. So lastly, all the resources that we have here from this presentation, from this keynote, you can go and scan this QR code and visit the website. If you have any questions, reach out to the Microsoft Developer Relations team. Myself, am I on LinkedIn, on Twitter, on Blue Sky, many other places. We have a Discord channel for AI Foundry. We have a Discord channel for GitHub Next, where developers can see what GitHub is working on in the future. The ability that you have to reach out to Microsoft is tremendous. If you're a software maintainer, we do have a GitHub community for software, for open source maintainers that you can also join. Search for GitHub maintainers community, and you can find that location. Lastly, your feedback is extremely important. So let's take a look at the survey here. So you can share your thoughts, your perspective on how to improve the way that Microsoft shares knowledge, especially for Java developers. If you have, yeah, there you go. So here's the QR code with the URL for your feedback for the Americas, but also for the overall Microsoft JDConf. We want to continue improving this conference, this virtual conference, as a way for us to bring community speakers to participate, collaborate, and share with you, with the audience, with developers from around the world. What can we do with technology today and tomorrow? And how can we help us developers be more productive, better, high quality, high security, and so on. So thank you so much for sticking with us for the last 4 or 5 hours. This was a great show. I appreciate all the speakers that participated in the Americas time zone. And stay tuned. We still have 2 more time zones to go. The ones for Europe and for European time zone, European-friendly time zone, and the Asian-friendly time zone. Go to jdconf.com and stay tuned. Thank you so much.